What's up, Captivine? Beyond Belief. Good to see you guys. Oof. Yeah, it's been about 7 months since I came to USC, so I figured that's gonna be the next school I go to. So here we are, back at it, at USC. See how it goes. Hopefully we get a few conversations. Sir Turtle Otter, what's up? Pie-Eye Piper. What's up, Nat? Renewed Awareness, Selenelian, Tina, Lalo, what's up? Lalo, love your work. Wondering if you ever heard of the YouTube channel K-Pod-G. She covers a lot of the same stuff that you talk about. No, I never heard of that channel. May give it a look. I don't know. We'll see if there's anything relevant. Would like to see another discussion with a lecturer or professor. I know I would love to have a conversation with some kind of professor, right? Just to highlight that even professors, even professionals in this field of science, right, or astronomy, right? It'd be cool to highlight how even they don't have anything physically to back up the belief, their belief in the globe Earth, right? So that is all that we're gonna get out of that, which will be great, obviously, just to keep highlighting how the experts don't even know why they believe it. They just believe it because that's what they were told as well. And now that the fact that they have years and years invested into their career, right? They're not gonna be easily I don't even want to say convinced, because I'm not trying to convince anyone. It's gonna take a lot longer for them to accept the facts, because they have a lot more invested. So professors are definitely gonna have the majority of them, right? I can't say all of them, right? Because obviously people are different. You might have some professors that in astronomy that will be open-minded, right? Obviously it'd be a very small percent, but it's possible. Let me bring on my phone because the comments are kind of scrolling by. What's up, one man? Gaining wisdom. Did you know that 4 planets aligned last night in the sky just before sunrise? What do you think the stars we call planets do move around? I mean, it appears that it's the sky that's moving, obviously, you know, because there's no device that, you know, here on Earth that can detect the spin, you know? So it's either the sky is rotating or the Earth is rotating, you know? And again, there is no device on Earth that can detect a rotation, like, you know. So yeah, it'll be a good assumption to say that the stars do rotate, you know, and it's not the Earth that's rotating. I'm finding slightly a small amount of people trying to listen to the other end of the stick when it comes to this reality and what we have been told. Not many, but more for sure. I know. It's I think this whole motionless flat Earth, or like the mainstream flat Earth, in my opinion, is kind of like giving this false perception, in my opinion, that oh, like it is moving forward. Look, people are waking up, right? Especially with these mainstream flat Earth channels that have a lot of subscribers, right? Kind of gives that illusion that it is a lot of people, right? A lot of people are waking up and blah 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 blah. But the irony is that most of these motionless flat Earthers have went from one rabbit hole into another, you know. So it's like they're not really independent thinkers like they think they are, right? So they're part of the problem that they're claiming there is. You know, the irony, right? That's like Dunning-Kruger, literally. Yeah, I think it's just kind of giving that false perception that it is moving forward, and in reality it's not moving as... It is moving forward, but not as fast as we think. It's not as, you know, as big as we think. It hasn't spread as much as we think, obviously, especially the real facts. You know, the fact that there is no physical downward acceleration in free fall, which is the #1 lie on Earth, right? Which is literally the lie that fuels the entire whole globe Earth model, the whole heliocentric model. It's that simple lie that objects accelerate down in free fall, right? So obviously that's not being talked about in the mainstream at all. You know, not within the flat Earth, you know, mainstream crowd, or the main mainstream, right? So yeah, it is moving forward, but it is moving forward pretty slow, you know, unfortunately. Like even me coming out here and presenting the facts to people straight up, you know, even that, you know, I can only plant a seed. Who knows how long it's going to take for these people to actually contemplate and realize what I'm saying is true, right? Again, based on facts, and I'm not just saying, you know, these things based on the demonstrations and how matter behaves. So yeah, it almost feels like it's at a standstill, you know, like literally, I'm not even gonna lie, like it literally feels that way. And it's mainly because there's a lack of presence online, because obviously out in the real world you're gonna have even less of a presence, especially about this topic, you know. So you would think that at least online there would be some kind of presence, right? Real presence, at least, you know. And there is a lack of that, definitely. So, I mean, that's what shows, you know, that this topic is really, 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 really censored. You know, and they try to like muddy it, you know, in every way, shape, and form. You know, I mean, every trick in the book you could think of, they are using to distract from this subject, to distract from the simple facts that destroy the globe Earth. Right? This motionless flat Earth bullshit. It's only fueling the globe Earth concept. You know, if people haven't realized that, then again, it just shows that you're brainwashed. You know, you never broke through the brainwashing. You know, someone gave you a little bit of truth, you know, to get your trust, so you could get your, you know, to get you to trust them, and then they led you right into another fucking shithole. You know, that's what happened with this whole motionless flat Earth. You know, you were duped again. I hate to say it, and I hate to say it, I was kind of part of that crowd as well. You know, I used to say that the reason why things fall has nothing to do with the shape of the Earth, and I would dismiss that conversation completely, you know, the whole gravity talk, right? Little did I know that was the #1 proof that debunks the globe. Because you can't have an upwards rising Earth if the Earth is a globe. You can't have a ball, for example, right, pushing up in every direction at the same time. You know, that just doesn't work. But I even used to dismiss that whole conversation about gravity because I was ignorant to the subject, you know, of force and what's required for force, you know, and what causes acceleration, what are the effects of acceleration, right? Because people are claiming a physical downwards acceleration, right, in free fall. So again, understanding all of these simple facts about how accelerometers work, for example, you know, it's enough to dismantle the entire globe Earth concept, right? But the majority of flat earthers, so-called truthers, are not only ignoring that fact that destroys the entire globe Earth, but they're against it. So not only are they ignoring it, they're against it. That just shows how deep the brainwashing has gone for these people that just rather trust and believe in authority figure over their own common sense. Because at the end of the day, your common sense should be your authority. You know, that is where your decisions should come from, should stem from. Your discernment, right? All of that should come from your own common sense. That should be your authority. Be your own authority, you know, type of thing. Don't give that authority to someone else, and now, you know, you look for them for answers for everything, right? You giving away your common sense to someone else, guess what? They're gonna shit all over. They're gonna take advantage of you. And again, that's exactly what we're experiencing. The education system just literally brainwashes us to hand over our common sense, to just throw it away, you know, and just trust authority. Believe us, right? We've done it all. We've explored the entire Earth. We've figured out the universe and what it is, and where we are in the universe, and why we're here, right? And how it happened, how it was created, you know. And you just evolved from fucking monkeys, that evolved from fish, that evolved from bacteria, that came from nothing. So that's what you are, right? If that's not a fucking religion, I don't know what is. It's the most dumbest religion out there, in my opinion. It's the most fucking retarded one, by far. You know. So I'm hoping we get at least one right here. I notice every time I come to USC, it's like there's students walking by. You know, there's foot traffic. It's just not a lot of engagement for some reason. So I did look up like the rules here at USC, because I was like, you know, I've been wanting to go inside, right? But this is a private school. So I kind of did a little quick search, right? Like, oh, is USC open to the public, right? Like, or is it just, or is it literally strictly private, you know? And apparently it is open to the public, but it operates as a private facility, right? So it's kind of like double speaking, like, yeah, we are open to the public. You can come and visit. You can come in and view the campus, tour the campus if you like, right? But we're gonna operate if it's private, and the reason why they do that obviously is because is to control what happens inside. Get it, But I think it's funny how it specifically says that they are strictly against unauthorized demonstrations or camping, right? Now, what I'm doing, I don't know if it falls under a demonstration, because I know a demonstration is kind of, it's more borderline of like a protest, kind of, right? I would say a demonstration aligns more with like a protest. I could be wrong, I don't know. So what I'm doing here with the discussion table, I don't think, falls under a demonstration, right? But I guess it could, right? I don't know. What do you guys think? Do you guys think what I'm doing here with this table, is it a demonstration, or is it just a conversation table, right? So, what do you guys think? Oh yeah, USC has more rich kids than the public university. That's true. That is true. It is pretty expensive to come to this school. I think it's more expensive than any other because it's private, more than UCLA, UC Irvine, and UCR for sure. It's a presentation table. Yeah, I guess people could say like, well, it's demonstration, presentation, tomato, right? So I would have to probably ask for permission if I want to go inside, because obviously it says unauthorized, So if I just go in there and set up, I may get away with it maybe a couple times, but then eventually, they could fuck with me, that's for sure. Poor girl wants to marry rich girl wants to flirt. Rich man goes to college and the poor man goes to work. College is a gathering of picture to teach with. That's why we call the schools a college. Check something real quick. Everything physical needs something to push off of, even gases, yeah? Because gases might be, you know, invisible, some gases, but they're still physical, so that's true.
How much?
Pretty much anything that has mass, you know. Anything that has mass requires something else that has mass to push it. You know, that's another way to look at it. So again, a helium balloon has mass. So it requires something else that has mass to be able to push it, and that's the air. You know, obviously the air being more dense and having mass, you know, is able to push the helium balloon because, you again, mass pushing mass. And then the air itself obviously can't push itself, so the air itself requires another mass to push it. You know, so that will be whatever container, physical container the air is within. You know, and depending on the direction that container moves, that's the mass that's pushing the air, which is also a mass, and then that mass is able to push the helium, which is a less denser mass, right? Which is gonna be affected, you know, by that initial push of the container. You know, pushing the air, and then the air pushing the helium. So yeah, anything with mass that has motion requires something else that has mass to push it. You know, so when people are claiming, oh, objects accelerate down in free fall, right? Now we're claiming a mass is moving through space, so therefore this mass requires something else that has mass to be able to push it down. And that's where gravity becomes, you know, that's where the magic of gravity comes in to fill in that gap, right? Because the pulling force of gravity, obviously there's no mass, there's nothing flowing down, you know. So, and mass is literally, I mean, force is literally mass in motion. So if you don't have either, that's why it's imaginary, you know, for the people that don't know. That's why gravity as a pulling force is magic, and it only exists in people's imaginations. And it's, again, it's there to fill in the gap to why objects fall, because that's the only way you can push a globe Earth model. You know, without that idea of objects accelerating down in free fall, you have no globe. You know, so people have to imagine again, and that's why they had to come up with the bending and warping of space-time, because they know that there is no mass there. Like, obviously, it doesn't take a genius to figure that out, right? So that's why they came up with this theory of gravity, of the bending and warping of space-time, because now it's not mass that's making this object move. It's space that's flowing around you, not the air. It's the area around your reality itself. The space around you is bending and flowing and carrying everything down with it. Like, that's what they want you to believe. That's what people have to believe in order to believe in the globe Earth concept. You have to believe in this, that space is bending and somehow flowing down and flowing and bringing everything down with it simultaneously. And that's why there's no displacement of matter during that acceleration, right? So this flow, they claim, is a constant flow, but yet it makes objects accelerate down, right? From a globe Earth perspective, an object in free fall has to accelerate down, but it increases its distance traveled, you know, per second, every second, for the first 5 seconds at least, right? That's an acceleration, increasing the distance traveled every second more than the one before. What's up, man? You guys want to give it a shot? Alright, let's do it. 2 very easy multiple choice questions. So let's see if you guys get it. So here's the first one. So here I have 3 box trucks. They're completely sealed, they're all on a level surface, and they all have an apple hanging from a string. The only difference between these 3 box trucks is that one is at rest, one is accelerating forward, and one is accelerating in reverse. So out of these 3, which one is at rest? B? Yeah, you got it. Why would you say B?
because it's not. It's at rest.
It's at rest. Exactly. It's not swinging. Exactly. Which one's accelerating forward?
Hey.
Hey, would you agree?
No.
No.
I would say
what truck is accelerating forward?
which truck is
Yes,
accelerating
the
forward?
truck.
Oh, A. Yes.
Yeah. So truck is accelerating.
Yeah. Sorry.
No worries. Okay. So how do you guys know A is accelerating forward?
Because when you go forward, it's going to make the apple swing backwards.
Exactly.
Yeah.
Look, and I have an example here. So this ball represents the apple because it's swinging. So if I accelerate, it swings. It appears to swing back, but it's the container that's moving towards it.
Yes.
You got it. Perfect. And it's due to inertia too.
Yeah,
It
yeah.
remains in its position. All right. Second one, pretty similar, but instead of an apple, it's a helium balloon inside the cargo van, the cargo truck. So out of these three, which one is at rest?
B.
Okay. Yes, and it's for the exact same reason as the
Yeah.
first, because there's no motion.
Yeah.
Which one's accelerating forward?
A.
I think it's A again.
You think? Okay, I'm gonna help you guys out with this one a little bit. So this is a buoyant object. So this is floating in water, just like the balloon is floating inside this truck.
Yeah.
So this represents the. Now I'm gonna accelerate it, and I want you to pay attention what happens to the ball,
Okay.
right? Okay.
shit.
Right. So going back to this question,
Okay.
which one's accelerating forward?
C.
It is C. Do you guys know why C is accelerating forward though? There's two reasons why, this happens. This
No
effect.
idea.
No idea. So the two reasons is, the first reason is air is more dense than helium, right? That's obvious. And the second reason is the force. So depending on the direction of the force, that's going to determine the direction the balloon goes. So when I apply a force in this direction, all of the air that's inside the truck as well is being pushed in that same direction through space. And because air is more dense than helium, is able to push it along with it. So a helium balloon will always react in the same direction as force.
Right.
So that's reality. So here, let me show you this example I did.
I don't know if a 5th grader is getting that.
Oh, once I show the demonstrations, they get it. I've done a couple 6th graders and they got it right. So I did an experiment myself, and it's basically both questions in one. So I want to see if you guys can get it. Okay. So I put a helium balloon inside a cargo van and an apple. So did I accelerate to the right, to the left, or is it at rest?
Oh shit. That's it.
That's crazy.
All right.
Yeah.
So what direction did I accelerate?
You accelerated forwards.
Yes, because that's the direction the balloon got
Yes.
pushed. So here's a bonus question.
Okay.
It looks, when you're inside the cargo van, it looks like there's two motions, one of the
Yes.
helium balloon and one of the apple. It looks like
Yes.
they're moving away from each other, right? But in reality, only one has true motion and the other one has apparent motion. So out of the apple and the helium balloon, which one has true motion?
I think the apple has true motion, and the balloon.
I think the balloon has true motion.
Yes. Why do you think the balloon has true motion?
Because the balloon's moving
Through space.
Through space.
Yes, it's
while
being
the apple's
pushed,
just staying
being left
with it.
behind.
Yeah, yeah.
Exactly. So the apple has apparent motion. You got it. Perfect. You got the bonus one. So here's one last question before you
Okay,
guys go.
okay. I need
If
to
I have a
decide now.
helium balloon here on Earth and I release it, what direction does it go?
goes.
Helium balloon. You have it here on
Yeah,
Earth.
and
goes
release
up.
it. It goes up, yes.
Yeah.
So there's two reasons why it goes up. Why do you guys think?
Because air is denser than
Helium? That's
so
the
it
first
rises.
reason?
Okay.
So what's the second reason? Because the second reason has to do with why it goes up. Why not left and why not right and why not down?
Because it has something to do with gravity.
It does.
Okay.
So here's the thing. So so the gravity of the Earth, I know we've been told that
Yeah.
it's a pulling force of the Earth.
Yeah.
But I don't know if you guys knew, pulling force of gravity is only a theory because it has never been proven or measured or detected.
Okay.
So the fact is the force of the Earth is a push. So right now we're not being pulled towards the Earth.
Being pushed down.
No. We're being pushed up. So the Earth is literally pushing up against you right now, and that upwards
I
push
see.
is what's pushing up the air, and that's how the helium balloons go up. So
Okay.
yeah, so when you release a helium balloon and an apple, the
Yeah.
helium balloon and the Earth and the air have true motion, and the apple only has apparent motion down. So that's why gravity as a pulling force doesn't exist, and it's just a theory because objects don't accelerate down to the Earth. So the fact is, when you release an object into free fall, the object doesn't move down to the Earth, it's the Earth that moves up to the object. So that's the reality. So here's the real reason why I'm doing this. You guys believe the Earth is a ball, right?
Yes.
You guys understand that on a ball, up is relative. So if you're
Yes.
standing
Yeah,
here, up
yeah,
is this way, and if you're
Yes.
standing, up is in every direction away from the
Yeah.
center. If we could prove physically that the Earth is actually pushing up on us and not pulling us down, and physics shows us that buoyancy, how can the Earth push up in every direction at the same time if it was a ball?
Because it's spinning so fast. Is that?
Well, that would make things go away, push things off because
Yeah.
of the centrifugal force. So, how would it push up though? Because if it's spinning this way, it's not pushing in any direction through space. You know, so the answer is it would have to be expanding. So the Earth would have to be expanding to be able to push up in every direction at the
Is
same
it
time.
expanding?
Here's the reality. The fact is it's not expanding because the Earth would just explode, right? It
Okay.
wouldn't work. So in order for people to believe in the ball Earth theory, they first have to believe in gravity being a pull of the Earth. Because if we could prove that it's actually a push of the Earth, the entire whole globe Earth concept falls apart. So the fact is we live on a level plane that's pushing up in one direction.
So it's not.
It's not a ball.
You're saying the Earth is not a ball.
It's not a ball. It's a level extended plane. So that's the reality. So the upwards push of the Earth shows that the Earth is only moving up in one direction.
Wait, but you said that up is relative.
If you believe you're on a ball.
Then how would you explain the curvature of the Earth,
Of the Earth,
over
okay.
a long period of?
You're talking about like the
Over
horizon, right?
distance.
Yeah, the
Over
horizon.
distance,
Yeah,
yeah.
yeah. So when you go out to the beach, for example, and you observe the
Yes.
horizon and you
Yes.
observe a boat appearing to disappear over the curve,
Yes.
what happens there is we do have a limit of perspective. So we do have a limit to how far we can see. So
Yeah.
when a boat goes out of view, it's not
Yeah.
going over a curve. It's simply just going out of your field of view.
But like, if I'm viewing a boat,
Yes.
I've seen one go
Yes.
out of my perspective. It's
Yes.
not that my eyes are not able to distinguish the boat going over the horizon. It's the fact that the boat is like I can see the first half of the boat, but I can't see the second.
So
half.
the bottom disappears
So you're
first.
saying
Yeah.
that it's my eyes are only seeing the first half of my boat, but my
So
eyes
due
are
to
not seeing the
perspective,
second.
here I'll show you a graph that it'll kind of like show you it's right here somewhere. Oh, a lot of slides right here.
Okay.
But here we go. So perspective, we'll show you this.
Yes.
Okay, here it is. So when we're looking long distances, we know
Yeah.
these train tracks, we know that they're parallel, right?
Yeah.
But it looks like they're convergent, right?
Okay.
Because we have spherical eyes, we do have spherical vision. So even hallways, everything converges to a point, right? So here's a graph of how that works. So this arc represents our eyeball, right? If we're observing something above our head or even below us, the further it moves out at the same height, the lower it appears to get in our field of view, right? The further it goes out, that line gets lower in our field of view until eventually it reaches the eye line, which is our limit of perspective, and people call that the horizon. So the horizon is only apparent because when a boat appears to disappear over a curve,
Yeah.
we bring out a powerful zoom camera and we could pop the bottom of that boat back into view.
So
Proving that it's perspective, not a curve.
Where's the edge of the?
Okay, so the
where
edge
do
of
you
the Earth.
distinguish
So
the edge of the Earth
yeah.
then?
So here's the thing: the whole
People
edge
go-
of the Earth thing, in my
go
opinion,
around.
yeah, it's misrepresentation because we experience air pressure here on Earth, right? It's 14.7 at sea level allegedly. So in order to maintain air pressure, you require solid containment. So that's how you maintain air pressure in the car and your tire. So the Earth, in my opinion, is physically contained. So nobody's been to outer space. So outer space is just a concept as well, and it's just there to reinforce the globe Earth as well. Because physics here on Earth proves that the globe Earth is physically impossible. So
Didn't they just like go into space and take a photo of Earth?
yeah. So photos of Earth here. I'll show you a couple of images I have here. So these are official NASA images
Yes.
from 2002
Wouldn't you
and
see-
2012.
Wouldn't
Yes.
you see every continent in that photo if
Yeah.
Earth was
But here's the thing:
flat plane?
they admit these are all composites. So these are all
That-
Photoshop.
Oh, okay.
They're not real. They admit it. So they say that they can't go high enough to take a full picture of the Earth, even though they claim to have done it in 1972 when they went to the moon. But now they're saying they can't do it anymore.
What do you mean? What do you mean they can't?
They say they can't go high enough. That's what they say. They can't leave low Earth orbit. Low Earth orbit. That's what they say. That's why astronauts haven't gone to the moon again.
Well, even if you did go high enough and you took a photo of Earth, if it was
Yeah.
a sphere or whatever,
Yeah.
spheroid,
Yeah.
you wouldn't, even if you were high enough, you wouldn't still be able to get a photo of
So
everything because if you're looking at one side of the sphere, you would still see
exactly.
a picture.
So
of
everything
that.
they're
So
showing
what
us from
would
outer
be
space like this, that shows the Earth like this, they're all
Okay.
cartoons. The reality is the highest we've ever gone up is between 25 to 30 miles, and this is what the Earth
about
looks
the
like.
what about-
Nobody's been higher than like 30 miles.
What about the rocket that just went up?
Yeah, so these rockets that they're claiming they're shooting up to space, first of all, if you pay attention to these rockets, first of all, again, you know, there's nobody in these rockets, first of all, but that's a different topic. But second, these rockets don't go straight up. They start making a curve right away, and
Yeah.
they claim that they're going around the Earth, right?
You wouldn't need to go straight up though if Earth was a sphere because you
That's
could just go and exit the orbit of exit the atmosphere and then you would just get back into orbit.
Yeah, so
then
they
you could go
claiming
around.
they're going around the Earth's curve,
Yeah.
and then the rocket disappears from eye view, and then they switch to CGI, in my opinion, after that. once the naked eye can't see the rocket anymore, because there's people that obviously observe the rocket take off, but once the rocket is not visible to your eye anymore, that's when they switch to CGI and claim to go to outer space, which they actually don't. So here, let me ask you guys this, because if the Earth has curvature, we should be able to physically measure it somehow. Would you agree or disagree?
We can measure it.
Well, how do we measure it?
I've seen multiple experiments of this.
Sure.
You set up platforms of the same level.
Yes.
And you can get a laser through long periods of time. And if you shoot one on the level, the laser will not be directly straight. It'll be a little bit lower, and the
laser will be above, because technically that's what they're claiming, that the Earth is curving down,
It'll be above. So the distance between where the laser starts and
where it ends,
the distance where it ends would be the curvature.
It shows the curvature. Okay, so here's the thing. The reason, so I have a better experiment than that. So first of all, when you shine a laser through water, could we say that the laser goes straight or not?
Well, the water refracts.
Exactly. Did you know that the air has moisture? It's pretty much like water. It's a fluid. So there's going to be refraction when you shine a laser through the air. So it's going to be an inconclusive test every time.
But air does not refract light to the same extent that
I would
water
agree,
refracts.
but it still does.
It does, but
here's the thing though.
I feel like the moisture in the air is not significant enough to refract light into a beam. Like the light is not being refracted down or up.
But when we're measuring distance like miles, then it's gonna happen regardless, especially when we're measuring miles. Okay, but here's the thing though. If we're gonna measure for the curvature of the Earth, we want to know how much we have to be measuring. Do you guys know the radius of the Earth?
I don't.
You guys know? Okay, here, let me show you guys real quick. Okay. So the radius of the Earth that we're told is 3,959
wouldn't the
miles.
Earth have to be a... Okay.
Yeah, this is what allegedly what they claim the Earth is. Because they supposedly have satellites orbiting the Earth, so they need to know this radius of orbit. So, so they need to know the radius of it. So based on the radius of the Earth, using a simple calculation like the Pythagorean theorem, a squared plus b squared equals c squared, I mean, anyone knows this equation. You can calculate for how much curvature there should be every mile based on the radius. So it turns out there should be 8 inches per mile squared. What that means, in the first mile, it should be an 8-inch curve. Second mile, 32 inches, and by the third mile, there should be 6 feet of curvature. And in 10 miles, there should be 66 feet, which is like a 6-story building, right? That's a lot of curvature in 10 miles. So how do we measure for that curve? I'll tell you a better way. If we went out to a giant lake that was 3 miles across, for example, and we build a level structure above the body of water, the water, when it's at rest, is going to be parallel to anything horizontal above it, because when water is contained at rest, the surface always collapses to form an equal surface, which is level. That's what water level means. So they're trying to tell us that the surface of every lake is bending 8 inches per mile squared, but if we actually build a level structure over a body of water, it's going to show...
Doesn't that not account for like the topography of the terrain? Like, you can't just, like, there's mountains, obviously. Like, if you go and you're measuring the curvature of the Earth, and if you're walking across Earth and you reach Mount Everest, obviously you're not going to account for the altitude of the mountain in terms of the curvature.
That's why we're not measuring the Earth, we're measuring water, the surface of water, because the Earth is covered in water. So the oceans, for example, the term sea level comes from the oceans being horizontal. So the oceans are horizontal, not because the water doesn't have the ability to maintain shapes on the surface. So if you have a pool, you cannot make that pool maintain a shape on the surface. Water doesn't have the ability to do that. Is the physics of water debunked?
Maintain a shape, as in like...
Yeah, maintain a hump. Yeah, because if you believe the Earth is a globe, then every lake on Earth has to have a hump in the middle.
So wouldn't gravity keep the...
But now you're going to a theory now of a pulling force, when the fact is a push.
But isn't the push a theory as well?
No. Have you heard of the normal force of the Earth? You should look it up. So it's acknowledged even in the mainstream. But they invoke this pulling force of gravity because they want to lie to the masses. But they acknowledge the upward push of the Earth, because buoyancy is a push, 100%. So when you have a ball like right here that's pushing up in water, the ball's not pushing itself. The water's pushing it, but the water's not pushing itself to push the ball.
Isn't that like...
So it's all connection from the
Newton's
Earth.
law, where like... If you're going down in one force, the force is equal and opposite reaction. So it's pushing up against the force pushing down is pushing you against. So it's not just a push pushing you up, but it's a going down also pushing up.
Yeah, so here's what they did. So they're claiming that gravity is the flow of something in the background that's pulling everything down, and the Earth is resisting us, right? And that's why we have weight. The reality is the other way around. It's the Earth pushing up against us, and then we have inertia. So there's something resisting our mass from moving. So there is a background medium, in my opinion, or something that's causing our inertia, and that's why we have weight. Because it's the Earth moving up, and then our body has inertia. And,
All right. Well, wow.
well,
this is
So
very.
what's stopping this from just floating up?
flying up.
Yeah.
Yeah, the air is not dense enough to push it up like a helium balloon. So like this, the air is not dense enough to push this ball like it does like this one. So it just gets left behind.
Okay, but I feel like things.
So that's
that
being
are,
left behind because
things that
everything
are-
else is moving up.
Things that are less dense than air still don't just float. Like there's like materials like what's it called, like aerogel or whatever that they've designed that is like 99.99 something percent air, and it doesn't just float up.
Well,
You know, it's
that
not
0.1% I would say is enough to keep it down. Because you're saying it's mostly air, but then it still has a small percent that it's not air.
dense. You're
So
saying that anything that is less dense
then air will go up. That's why fire
But I
rises.
don't think that that's because that there's. That's just probably because it's less dense. But like, I don't. How does that prove that there's the gravity is pushing up instead of it's just less dense?
Yeah, so if you submerge like a beach ball, for example, underneath the pool, would we
Yes.
agree that we'll feel a tremendous amount of upwards push? Like we'll feel an upwards push
Yes.
if we try to submerge a beach ball underneath the pool, right? Because there's an upwards push there. Could we agree on that?
Well, it's displacing. It's like displacement. So like if you're
No, but we could put a rock or a bowling ball and it's not going to push up. It's going to displace the water, but it's going to go down. A bowling ball.
yes, because it's dense.
A beach ball will displace the water, but it's being pushed up.
it's heavy. Yeah.
Yeah, so here's the thing. If we were to elevate a pool and it's not connected to the earth anymore, right? And then we put that pool into free fall and you try to submerge that beach ball inside the pool while it's in free fall, it's not going to feel that upwards push anymore for the earth because it's not connected to the earth anymore. So buoyancy is an effect.
Because it's experiencing a different kind of motion. Like,
Well, you think that it's accelerating down, right?
well, that's
in free fall?
isn't gravity just like immense acceleration? Like if you're falling in an elevator, like I've seen this. If you're in an elevator and they cut the
Yes.
they cut the wire
Yes.
and the elevator shoots down super quick, you're gonna experience less and less of the pull because the acceleration of the elevator downwards is counteracting the gravity that's pulling you down. So you're gonna feel a little bit more weightless. Is that not?
Yeah, you do feel weightless in free fall, and that's because you have no forces acting on you.
Exactly.
Exactly.
Gravity. It's counteracting
But
the
if-
gravity that is pushing. If you're falling down, is that not counteracting the gravity that is pulling you down? So if you're accelerating, you would feel more weightless because that's counteracting the pull.
I see what you're trying to get to, but
Yeah.
here's the thing. Look, you believe objects accelerate down in free fall, obviously, right? So here's the
Yes.
thing. I did an experiment. So everybody's cell phone, everyone's smartphone, has a built-in accelerometer. So what that does is, you know how you could change your phone to portrait and landscape, and it switches based on because it detects the Earth's force. So I did an experiment with the built-in accelerometer because when you download an acceleration app, you're able to like see, when you have the phone at rest
Yeah.
and you accelerate it from being at rest in any direction, there's an increase in force. But in free fall, something different happens. But here, I'll show you guys real quick.
Well, if you're in free fall and you're accelerating at a constant speed, you're not accelerating. No, you're just like.
But that's the thing, though.
Acceleration is acceleration is not the same as speed. Acceleration is
Acceleration is increasing your
acceleration is
speed.
increasing
The
your
next,
speed. If
yes.
you're free falling, and say you're free falling from a high point,
Yeah.
depending on my weight, I'm going to reach what terminal velocity. I'm not going to accelerate.
Yes.
I'm not going to accelerate anymore. I'm going to reach a steady speed of
Fair
free
enough.
fall.
So this is a minute long, and again,
Okay.
I did it using an app in my cell phone, and anyone could do this.
Okay.
Okay.
The accelerometer is a device that detects the presence of a force or acceleration. For example, when at rest and connected to the earth, it detects 1 g-force. As soon as I accelerate it from being at rest, the accelerometer detects that acceleration by increasing the g-force. Whether I accelerate it to the right, to the left, up, or down, the accelerometer will always detect the acceleration 100% of the time. However, the instant I put the accelerometer into free fall, it detects a deceleration. It goes from 1 g down to 0. If the accelerometer was accelerating down in free fall, it would detect that acceleration by increasing from 1 g, not decreasing. Not only these,
It
the
was increasing,
accelerometer
though,
show
was it
that there's
not?
no detectable
No, the
acceleration.
instant I let it go, it went to 0 instantly. And the reason why you see a little bit of reading after that is because the air is trying to push it up as it falls down. But here, look, this is half of the video. It's
It
almost
also
done.
shows that the vector or force of the Earth is up. I switch to the vector tab of
Oh my God, why is it not coming up?
accelerometer, we can see when at rest on
Let me see. Let me
Earth,
take
it
this
takes
freaking.
So how does if gravity is pushing up, how does, like, we're taught that in
Yes.
like orbits and solar systems, like our gravity pulls things, our Earth's gravity pulls
Yes.
things closer to it. So how would you explain things staying in orbit? Like the sun in
Yeah.
the center of the solar system
Yeah.
has a massive gravitational field. It keeps everything in orbit. It
Yeah.
prevents things from just floating away.
So-
how does that happen?
So this, you're
If it's pushing, then
Yeah.
why don't our solar system? Why isn't it just like? Why aren't we flying out into space?
Yeah, so you believe in the heliocentric model of the
Yes,
universe, right?
yes.
So the fact is, the Earth, we don't live in a heliocentric model. We live in a
Okay.
geocentric. So like I said, outer space is just a concept that only exists on paper. So they have equations to explain
What
how
about the sun?
the sun is real. Obviously, it's there, but nobody knows exactly what it is. Like they're claiming that it's like gas, but nobody
So
knows.
What do you mean? So
I-
what
I-
else would it be?
I have no clue.
Isn't it just a ball of? It's like a
I don't even-
nuclear reactor in the sky, a ball of gases. And
Sure, that's what they tell us, but I don't believe that. The fact is, nobody knows exactly what it is. We just have assumptions. But at the end of the day, looking at the sun tells us nothing about the shape of the Earth physically.
it doesn't tell us about the shape, but it tells us about like the what's it called? Like the forces that are keeping. Like why isn't Earth just floating off into space then? Why is the sun? I mean, we can literally measure the distance between the Earth and the sun. If the Earth is pushing, or the sun's gravitational push, in this case, if you're saying that, is stronger than the Earth's, why wouldn't the sun just be pushing the Earth away, like into wherever you believe?
Well, you believe that. I will ask you, in your model, why doesn't the sun pull the Earth into it and burn it?
Because
Because the sun's obviously way bigger than the Earth in your model, right?
it's so far away. I mean, I think it is going closer, but I think it's so far away that, like, all the gravity. I mean, I'm not an expert in
So the way I
space,
see it, in
but
my
I think all the gravity, like, we have different planets in our solar system.
Yeah.
Like, they're so far away, the gravitational pull decreases over. Like, we're really, really far away from the sun. The sun's.
fair enough. I mean, I don't know the exact distance to the sun,
I mean,
but
someone probably does.
so here's the thing: they claim it's 93 million miles away.
Okay,
That's
yeah,
what they
there we
claim.
go, okay,
But
yeah.
they started off when they first claimed it was 1 million, and then little by little
Yeah.
they just been tweaking it. That was back in the maybe in the late 1800s, early
Yeah,
1900s.
we can. I mean, I can probably buy a telescope from
But yeah, but
Target that can tell me how far away the sun is.
But we're going off topic again because
Okay.
talking about the sun and the moon and the lights,
Yes,
it's a red
yes.
herring when it comes to the physical dimensions of the Earth and the physical geometry of the Earth.
I mean, we can take a photo of like Jupiter and see that it's a sphere.
I would say you're assuming it's a sphere.
I mean, if you buy, I have friends that have like big telescopes. You can take a photo of like Saturn and see Saturn's ring and see the thing. Like, why would we assume that Saturn is just like a sphere with a ring and Earth is just like a flat?
Well, that's the thing. I don't know exactly what the planets and the stars are,
Okay.
but to make assumptions about these lights in the sky
Yes.
to try and prove something physical here on Earth, I think that's illogical. Because you're making an assumption to make your point, to prove a point, which is not.
What would be more illogical, though, looking at every other planet in the solar system with my own eyes
Yes.
and observing their shape, and then assuming that Earth's is different, or assuming that, okay, everything else looks like that, maybe Earth is the same. I feel like that would be more logical than assuming that Earth is a different shape than every other planet.
Well,
So-
I would say the Earth is 100% unique. So there's no other
why?
place like it. Well, in my opinion, it's because it was created. The Earth is a creation, 100%.
from like God or something.
I don't know. So religions,
From a thing.
from
From a
a
thing.
higher power, you could say. I don't believe in any religion because religions are just there to control people. I acknowledge that this is a creation because that's what
Yeah.
physics shows me. But other than that, I don't buy into any religion. So the heliocentric model, ironically, is the biggest religion on Earth, and I'm gonna tell you why. Number one, because it's based on faith. And number two, because it gives you a creation story and a purpose here in life.
Why is it based off of faith?
Because you have to believe in the Big Bang and evolution. None of that has been
don't.
proven.
You don't have to believe in the Big Bang to order a telescope on Amazon and point it to Jupiter and say Jupiter's a sphere.
even if it was a sphere, which I don't think it is, I think
Okay.
it's just a light. I don't know what it is three-dimensionally.
Okay.
But you think that you can actually stand on some of these lights in the sky, right? Like Mars. You can physically stand on it, right?
I mean, no.
No,
Well,
let's
yes,
say
you can-
theoretically, like if you had like the equipment,
Yes.
you could
Well,
you could physically stand.
we've sent robots onto these things.
Okay, could you stand on a rainbow?
Well, a rainbow is not the same as Mars. A rainbow
Well-
is light refracting through
Let
air.
me show you.
Mars is rock.
Well, here's what.
I can stand on rock more than I can
Yeah.
stand on a flashlight.
Yeah, so these are images, close-ups of the stars,
Okay.
and these are image close-ups of the planets, right? So this is what NASA shows us Mars looks like
Yeah.
with their cartoon telescopes.
Okay.
This is what Mars actually looks like in reality.
Yeah, but NASA's telescope compared to a Nikon P900
Yeah.
is like a toy airplane compared to a Boeing 747.
Fair enough. But here's the thing: I shouldn't be able to zoom in to these lights. For example, all these stars. If these stars are supposedly way further away than the planets, and I'm able to bring them into focus with the same zoom. That shouldn't be possible because they say the planets are within our solar system, right? But the stars are light years away. There are other suns that are way further light years away.
But they're light.
But I'm able to bring them both back into
Yeah,
focus.
but
Planets and
stars are different than planets. Stars are big, like the sun.
Yes.
Big ball of gas. It's a nuclear
Sure.
like reactor in the sky, like burning super bright.
Yeah.
That's obviously going to be significantly brighter than rock.
So here's the thing. I don't know if you knew, but you can look
Yeah.
this up. The planets used to be called stars back in the day. So the word planet comes from
Yeah.
wandering star.
Okay.
So they're no different than the stars. The only difference that they are
just
is
because
they have their
were
own unique.
called the same back in the day does not mean that they are. The
No,
same.
my point is that people acknowledge that they were pretty much in the same distance from us, and the only difference between them is that the planets have their own unique path. They're not fixed with the rest of the stars. That's the only difference. You think
what?
that they're like, so the planets,
Yeah.
they don't rotate fixed with the rest of the stars. The rest of the stars have constellations, so
Well,
they
the
all
rest of the
rotate
stars,
together.
well, half of the stars are not in our solar system.
So the planets just have their own unique path. But again, we're going off topic because none
What
of
do you
this
mean?
proves the shape of the Earth. You're assuming that this is a real image, and because
Yes.
and let's say I gave you that.
Okay,
Let's say
sure.
this was a real image.
Yes.
This is your proof that the Earth is a globe.
Well, if I don't know how many planets are in the solar system. Like,
Okay, that's another assumption that
Sorry.
you've been told.
okay.
Because basically,
If I have here, let me pull this up. I have a friend
Sure.
who I know is not doctoring images,
yeah,
who I went to high school with, who has a good telescope.
but he's not an astronaut though.
He's not an astronaut,
Right.
but I mean, you're not an astronaut.
Sure.
If he's taking a photo of, let's see, he can take photos of the Milky Way. These are crazy photos that he can take.
Okay, that
With-
looks like a cartoon to me, but
I mean,
sure.
it looks like a cartoon to me, but I mean, he knows better than both of us, I would assume. If he can take a photo of the moon,
Okay, yeah, sure.
and he can take photos.
I will admit the moon does look solid. It does look
agree.
solid. I agree.
I agree.
But
So-
just because it looks solid, I'm not gonna make an assumption that it is solid and also a sphere, and
I
then
agree.
also and assume that the Earth is a globe based on those assumptions.
I agree, but
that doesn't make sense.
But I feel like at that point you need to compile. I think it's easier if you use all the information given to us to assume, okay, we won't go into the moon landing, but we can shoot lasers to the moon that bounce off,
back.
and we can tell, okay, this is not just like a hologram. This is this far away. We can measure the actual distance. We can fly by it on spaceships that are recorded throughout the whole flight. Like the SpaceX ships they have cameras on them, the whole thing. They live stream them. What would be the point of sending all these rockets up to the moon and faking all of them? Like, what's the point of
The
that?
point of that is
How much-
because the globe Earth concept doesn't have nothing physically. So everything that has to do with real science, natural science,
Okay.
debunks the globe Earth. So they have to go into these abstract
What do you mean?
things, like going to the moon, for example, and all these CGI images they show us because
Yeah,
the
but
globe Earth has nothing
Elon
physically.
Musk has no skin in the game of the mass propaganda for the world. Like, he's a private. Sure, the government could send up people to the moon and fake it for to try and calm the masses about the Earth, but we have now billionaires that are privately funded companies that purely are going up because they want to have billionaire clubs on the moon or whatever. I don't know why they go up, but still, like, if they're going up for their own reasons. They're not going up to fake images and try and distract the masses. These guys don't give a shit about distracting the masses.
Well, first of all, Elon Musk, I don't know if you knew, he does get a lot of grants, government grants.
Okay, what about Richard Branson? He's just like an eccentric billionaire that parties on an island.
He took an airplane, right, to the edge of space, right?
Yeah.
I would say he just took an airplane, flew it really high, and that's it. They used the
Katy Perry went on a rocket.
Here, let me show you. So the only place you're ever gonna see curvature of the Earth.
Okay.
You guys are familiar with GoPro wide-angle lens, so the fisheye lens.
Sure.
It warps horizontal lines. So when somebody's high altitude and they record the horizon curved, it's because they're using the action camera.
Yeah, but if you go high, I mean, I don't know how high this is probably like a paraglider.
This is 20.
He goes higher.
This is 20 miles.
Yeah, but the Earth is huge.
And this is without a GoPro lens.
The Earth is massive.
And that's why you can't take a picture of the entire Earth, because we can't go high enough.
There's no way that these are not doctored, because these are corrected, you're saying?
There's videos of these balloons going up, because these are giant helium balloons that people send up.
But you're saying this has been corrected to correct the curvature?
No, they use standard lenses from the start. So they use like a cell phone camera that's standard. It doesn't have a fisheye lens.
Do you think that they're not
They're
going
like
high enough
12-hour long
to see
videos
the
if you guys want to
curvature?
watch them when the balloon goes up.
Okay.
They're really long because it takes a while for the balloon to reach this height.
What's the point of lying about the Earth being flat, you're saying?
So you guys are jumping to the motive where you guys haven't even looked at the crime. So the motive of the crime
Why
is...
it's a crime.
Well, first of all, if I tell you the why is a crime, when you haven't even looked at the crime, you just...
What is your hypothesis?
My hypothesis is that the Earth is not a globe. The Earth is not flat.
What do you guys think about the moon?
I think it's a sphere that's like rock.
Why do you think?
And how does it get its light?
How does it get its light? What do you mean?
When the
sun shines, light bounces off of different surfaces.
Okay, you ever heard of a solar eclipse?
Yes.
How does it black out the sun then?
Because it moves in front of it.
But if it's in the luminary, it would shine through it.
No, it wouldn't, because it's rock. So like if I have a flashlight,
What do you think about that?
No.
If I have a flashlight that's shining light like this, and I have a rock, and I move the rock in front of it, the light is going to go around the rock. It's not going to go through.
But
the
if
sun.
it's away from the sun, it'll shine through it. That makes no sense.
What do you mean? It doesn't shine through it.
This is an observation that
The
debunks...
sun never shines through the moon. It can hit the moon, and the light can bounce off the moon. That's how we see. That's how we see things.
No,
Our
outer space is all a concept.
Light bounces off of everything.
The Earth is a
every
system,
surface,
you know,
and
and
goes
everything
into my
that we
eyes,
see is
and that's
part of
how
the
I
Earth
see.
as well.
That's how our
the
eyes
sun,
work.
the stars,
So
it's all part of the
sun
Earth. So the sun and the moon
hits
are
the
very
moon, the
small
light
compared to
and
the Earth.
bounces off,
They're within
goes
the
into
Earth.
my eyes,
So
bounces off
nobody's
of
been
everything.
outside
That's
of the
how
Earth, because the Earth is contained, in my opinion. So we're inside of
So
it.
solar eclipse
You know?
is that's why it's rare, because it's the timing.
The Bible
rare
talks
timing
about a
when
dome.
the moon
I don't make any claims that I don't
passes
know.
a perfect point from
Oh,
the sun.
No. So the dome, in my opinion, is 100% more probable
Just
than
about
obviously a
covers
globe
it.
Earth.
Even during a solar
You know,
eclipse,
but
you
I don't know
can
what the
see the
container
light
looks
of
like.
the sun.
For all we know, it could
going
be
around
like a pyramid shape.
So it
you know,
never goes through.
you know?
Gravity and all that
That's what I'm
So gravity is
then
a
how
push
does
of
it
the
get
Earth.
lit up when it's away
Physically
from
prove that.
What do you
So
mean
the
how does
Earth
it
is
get lit
pushing
up?
up against you. It's
You're
not pulling you
saying
down.
the moon is a rock receiving light from the
Yeah,
sun.
the normal force.
Yes.
Exactly. That's the only
So
force
if
that
it was a
exists.
rock receiving light from the sun, it would shine through it.
So
Why
here,
would it shine through it?
no. So here's how easily you debunk the moon being solid.
Okay.
You can look this up. People have taken photographs of stars through the moon. So when you have the moon during daylight, some
do you mean
people have
through the moon?
photographed stars behind the moon, like through the crescent part.
don't think that.
So the flag of Turkey, you know how they have a star around the moon? That is a symbol of these observations. So that proves that the moon is not solid.
Does not prove that the
No.
moon
They're
is
just
solid.
no. I'm saying the
It's ancient
observation.
symbolism, you're saying.
It's a symbolism.
That symbol is way older than the country of Turkey.
Yeah,
agree,
my
I
point
agree.
is that symbol of the star being there's a lot of images and proof that there's stars being photographed through the moon. Put it that way.
Now, have you ever
You have to look them up.
see the sun shining out and how it has rays around it?
Yeah.
So what about, you ever see it when it comes up or goes down, like right before the sunset? It's a perfect sphere. It doesn't have any rays. Why is that? Like the moon. You know when you see the moon fully lit up on a full moon? It's perfectly round and there's no rays around it. When the sun goes down, the same thing happens if you look at the sun.
What do you mean the moon has no rays around it?
Yeah, like right now when you look at it,
Right now when you look at it,
has
there's
light,
rays.
like rays going out of it.
But when
it's
the
by the
sun goes
horizon,
down, when it's at the horizon, it's a perfect circle, just like the moon.
yeah,
is
you
when
could
it's
see like
fully
the
lit.
outer circumference of the circle.
Okay. Yes, but what does that prove?
Yeah, I know. What is that?
What I'm saying is, I don't think the world has a real understanding of the sun and the moon and these elements, and that's why he's bringing up these type of.
I would argue that we don't have an understanding, but I'm saying if we went into campus and we brought some sort of physics professor to come out here, I guarantee you he would be able to explain why there are rays on the sun and not during
Is
sunset.
an explanation of something proof of something?
Yes.
Yeah, so I can explain to you how Superman flies. Does that mean
an explanation itself is not the proof of something?
Exactly.
But an explanation with data and evidence to back it up is.
What if that
So
data
you
and
have-
evidence is not rooted in nothing physical and it's just theories?
Then it's not. But if say you bring together a group of 100 science professionals that all have experience, like the scientific process, you have to have multiple different people that come in and review work, review everything. It's not like they're making it up. If you have a group of 100 scientists that telling you one thing that have studied their entire life, I do not study the sun, and I don't know why there are rays right now of the sun, why there's not. But I think that the odds of them being correct are significantly higher than me doing my own research online and
But how did
having
they
my
get
own
to their
evidence.
conclusions? They were doing their own research.
Exactly. But all that research is publicly available. You can go, it's not like they're hiding all their research from people. I think it's, if you go online, you can read thousands and thousands of pages of scientists that do these experiments with like real technology. This is all documented by not just the government and privately funded organizations, by like educational systems of people that have no motives behind it, just for the cause.
I mean, all of these
just
people
for
are being paid,
curiosity.
though, so there is some kind of motive. It could
I
be an
mean, they're
alternative
being
motive.
paid, but not from people that have the backup. They're being paid from like a school. The school pays them. They give grants to try and do their research.
Okay.
In the name of science, in the name of developing and trying to improve humanity. But I think that I would agree that they know better than I do.
Okay, let's say.
And I think that.
What are these right here?
So these are images of the stars when you zoom into them, and these are images of the planets when you zoom into them.
All
So,
right, sir, I gotta go to class.
all right, no worries,
but
man.
this
Here,
was-
I'll
this
give you
was
my
good
channel.
talk.
You can
Okay.
check it out. I go to other universities as well.
Yes.
Talk
Nice to
about
meet
this.
you. Nice to meet
take care,
you.
man. Take care. Yeah, so these are images of the stars. So, do you believe the Earth is a ball? Let me ask you that. This is what
It's
Jupiter.
always been an interesting question. I think it. Let me hear what you have to say about
So,
it.
yes.
What evidence, what theories, what...
Yes. So the whole globe Earth
Because
concept.
that's a big lie then if they lie about that.
I'm glad you
It's
see
like
it that
a lot
way.
of things. And
Yeah.
my thing is I test all things. I choose to have discernment.
Yes.
And of course at the end of the day we have to make a decision.
Yes. You got to be presented with all of the information first,
Exactly.
and then
If you look at something and say, oh no, then how are you going to learn something?
exactly.
You dive into it, then you figure out if it's true or not.
Exactly. You got to use your own
And
discernment.
then what is this picture then?
So these are images of the globe Earth, but these are NASA official images, and they call them images, not photographs.
Do you think the maps are real?
No. So all the maps of the Earth are wrong.
So like a world map, they just fabricate.
So the closest thing, in my opinion, to the Earth, what the Earth looks like. Again, I don't buy into any
So
map,
then
but this is the closest thing.
When a pilot flies, then how are they navigating?
They're using GPS, so everything's already part of the grid. So when they're flying to like
But wouldn't
Europe,
GPS mean there's a satellite looking
no, it's all ground positioning system.
ground? Oh, that's what GPS means.
GPS.
Ground position.
Yeah.
So what are the satellites? Is there satellites?
So no satellites, they're called satelloons. So they have these machines, so satellites attached to giant helium balloon, and NASA is the #1 buyer in helium. So ironic. So they buy helium balloons and they send them up.
But is there satellites like they say
in outer
orbiting
space.
around?
No,
There's not.
Nobody's been outside of the Earth. All that, everything that
The
they
moon
claim,
landing was not. You don't think the moon?
it's all made up. It's all made up. So it's all there to make people believe that the Earth is a globe. Because physically here, the physics here on Earth.
And why was
proves-
it? What advantage does that lie have in whatever?
Right. So I'm not the one lying, so I couldn't tell you 100% why, but I can give you my theory. So I think they're lying to us because it's easier to control someone that's mentally crippled, and they're mentally crippling us when we're very young to accept the globe Earth, because in order to
That's why they build these schools
Yes.
to brainwash people.
Yes. So that's what it's all about. It's about controlling us. So they dumb us down to that we're more easily controllable, so that we do what we're told easily, so that people don't stand up against injustice, for example.
I'm a freedom fighter.
Exactly. That's literally what I stand for, and this is the one thing that's just
My thing
really,
is, why is this? So I mean, I understand that you're out here
yes.
about this, but why would that part be so important in fighting the
Yes.
injustice?
So-
Because there's a lot of other things that where you think solving that problem will make people question a lot of other
Yes. So here's the thing: in order to be able to stand up to tyranny and to be able to stand up for yourself, you need to have your own discernment. You need to trust your own common sense. If you don't have common sense, then you're going to be easily tricked, swayed, controlled, right? So you need to trust your own common sense and discernment first to be a strong individual, so that then you can stand up against injustices, right? If people believe in the globe earth concept, that shows me that you're not thinking for yourself. That shows me that you're just putting authority over your own common sense, just like this kid was saying. If we have 100 scientists here, they're going to tell me what the sun is,
I still don't think they quite understand about the moon also, because why would it black out the sun if it's an illuminary? Because if you have a rock
Sure.
that shine, if you look at any stones and you put light through it, it'll shine.
Sure.
So if you put a stone in front of a light and it blacks out, that means something else is going on.
Fair enough. Yeah. I wouldn't know exactly how the sun moon works, but again, I think that they're lying to us it's like a cheap shot on our common sense to believe in the globe earth. That just shows that you have some kind of allegiance towards the people that run the system, to believe their lie. This is their lie. I didn't come up with this whole globe earth, bullshit. But if you believe it, you're willing to believe in anything else. So these are demonstrations that I show to debunk gravity. So to debunk gravity, that's a pull. So gravity is not a pull of the earth. So everybody believes that when I release this into free fall, that this accelerates down to the earth, right? Everyone believes it. But the fact is, this doesn't move down to the earth. It's the earth that's moving up right now. And then when something's not connected to the earth moves up to meet this.
Say that again?
So when something is not connected to the earth like this in free fall, it only looks like this moves down towards the earth, but that's because we're connected to the earth and the earth itself and everything.
It's like us floating in an elevator coming up and like touching our feet.
Except this is not just floating, it's still moving up, but it's slowing down. So the fact, because
so
everything
is it in constant motion then,
yes,
moving up?
Yes, it's a constant motion right now, moving up because I'm holding
but if it's flat, then it would always be moving up.
Yes, it's always moving
always
up.
moving up.
It's always moving up, and that's what
so
gravity
what's space?
is.
Is space unlimited?
That's the thing, though, in my opinion. But again, it could be, because in the globe Earth concept, they claim space is infinite. So space could be infinite. I don't deny that. But in my opinion, the Earth doesn't move in a perfectly straight line. So in my opinion, the Earth does have a slight deviation. So it's part of a cycle, in my opinion. So it doesn't just move through space infinitely. And why do I think that? Because you obviously you heard of the high tide and the low tide, right? The oceans, they have a high tide and a low tide. And
isn't it controlled by the moon?
No, that's because you believe in a pulling force of gravity, but everything's a push. All the forces here on Earth are push. So the fact that the Earth is pushing up, that's what levels water out. Because if you have a water bottle like this and you push it this way, the water levels out that way. But if you push it this way, the water levels out that way, perpendicular to the direction of vector. So the fact that the water is leveled out this way, perpendicular to the vertical motion vector, shows that there's an upwards push. Not only that, the tides show that the oceans are deviating. There's a slight tilt. That's why you get a high tide and a low tide at the same time, because there's a tilt with the oceans. That shows that the Earth itself is not moving in a perfectly straight line, because the oceans are constantly reorientating. And that's why the oceans move, in my opinion, because the Earth is not moving in a straight line.
Did you do most of your, sounds like you did most of your research in like different areas, or are there specific types of individuals that you listen to?
There's one individual that I listen to right now. He's from Scotland. So, and other than that, I don't really listen to anyone else. I used to listen to some flat earthers, mainstream flat earthers back then. I don't listen to them anymore because they're obviously controlled. So the mainstream flat
a lot of people mock the flat earthers online.
100%. The flat earth is a psyop, and I'm gonna tell you why. Over 95% of flat earthers, especially online on YouTube and big channels especially, they all claim the earth is motionless. So they deny the push and pull of the earth. So they're coming up with their own physics to why objects fall. It's just magic. It's retarded. The whole motionless flat earth, it's retarded. And the whole flat earth versus globe earth, it's a false dichotomy. Just like Democrats versus Republicans, they're both being controlled by the same entity. So they're both being controlled by the same party. So it's just a distraction, this whole motionless flat earth versus globe earth. The fact is the earth is level because it's pushing up. And level is an orientation relative to the force, which is up. The globe earth just inverted that. They're claiming the force is down, which is not. It's level. Yeah, it's like.
So then what is it surrounded by?
In my opinion, it's surrounded by something keeping the water in, because the water has to be contained. So I don't claim this, but if Antarctica was real, it would just be a ring holding in the ocean water.
A ring of ice or something?
A ring of ice, if anything. But I think it could be more land. It could be the container itself holding the water. You know, I don't know, because in my opinion, the Earth is being contained somehow physically too, so we can't leave it. I don't know what's outside of it. Nobody knows what's outside. I think what's outside of it is the beings that created it. In my opinion, they're probably right outside of it. You know, I don't know. I have no idea, but it is intriguing to think about what the fuck is really outside of the Earth. If we could even go outside of the Earth, I don't think we could. I think that the governments have found the container, and I don't think they've broken through it. I don't think they could break through it. You know, in my opinion.
Maybe they've been trying and something's been stopping them.
Yeah, maybe. But here's the thing: the deepest we've ever drilled is only 8 miles. So
To the Earth?
To the Earth. That's the deepest we've ever drilled. 8 miles, which is nothing compared. You know. So I think there's limits that we can pass, get past it. You know.
That I disagree with.
So that's just the way I see it. You know, our technology here, I think, is not strong enough to be able to break through the reality. Does that make sense? So people claiming that they're going outside of this reality into other environments, you know, other planets and shit, all that's made up. You know, it's literally just stories to back up the globe Earth model. So everything about outer space, pay attention, it's all CGI. It's all cartoons. Nothing about outer space is real.
Well, what about those stars that you mentioned?
The stars, that's as real as they get. You know? So I think the stars are kind of like a rainbow. It's just a visual phenomenon. And people just make up stories about them and people believe them. And it's kind of weird, but the stars are no different than a rainbow in my opinion. Because I don't know if you knew this, in the night when you can see the stars. And what?
Do you believe in stories?
Nope.
At all?
When it comes to physical reality, I don't believe any story. So if somebody's making claims about the Earth physically, I don't buy into any story. I want you to show me physically what you're claiming. You know, I need a demonstration. So if people are claiming the Earth has curvature, for example, I want to see you measure that curve.
That's kind of what he was claiming, that there is scientists that demonstrate this thing.
No. So the what he's saying is
You
just
don't trust them.
So there is a lot of consensus in this scientific community, in the mainstream scientific community, and that's enough to convince people. So because 100 experts said so, now it must be true.
That's like the people who put together the Bible. There was like
a bunch of
people that
consensus.
said these are the ones in the book. They put it together, and then
I think it's funny how how many, it was like 12 or 13 disciples, right? I think only 12 or 13 people have gone to the moon, supposedly. So it's like another Bible story, pretty much. You have your 13 disciples that supposedly went to the moon. But they're just stories, you know. So what? Let me ask you this: if you believe the Earth is a globe, which I don't know if you do, but if you do, why do you believe so?
The significance of why this part is so important.
Well, it's because if you believe the Earth is something that it's not, then you're being disconnected from your true self, because you're being disconnected from your true environment. Like you believe the Earth is something that it's not, then you're gonna have a false perception about what you should be doing here, what your purpose is here, and who you truly are. So you're gonna be living someone else's lie, in other words. You're living someone else's idea of a life, which is not real. So we're technically living a lie at the end of the day by believing the globe Earth and believing everything that comes from these people. Because after the globe Earth lie, what comes after that? Well, it comes a way of life.
What else do you think is a lie that they're lying?
Well,
that's important to like.
Well, in my opinion, there's no bigger lie than this. But after this, I would say, I mean, we're being lied to about the economy, for example. Like, you know, the value of money. You know, it's not even backed by gold. It's just made up. It's just a belief. So the dollar has value because we just believe it does. And that's what.
That's I understand.
Yeah. So a lot of people, again, they just don't want to think for themselves nowadays. Because I guess people are just too lazy now to think for themselves. They don't. So then people lack critical thinking skills nowadays. So people just go with the crowd. So So that's how they're controlling us. It's just, you know, through crowd thinking and group thinking. You know, I guess people are too scared to go against the grain, and that's why I'm literally the only one right now, besides the other guy from Scotland, that's advocating for this. That's actually pushing real physics that debunks the globe.
Would you say it's like a disc shape then, or would you say it's like
the surface of the Earth is 100% level, but it's obviously mountains. There's valleys, so it's obviously not perfectly straight. It has high points and low points.
There's some significance to the round Earth because wouldn't it? So then, what shape is it?
It's a level plane. So the surface of the part of the Earth that we live on, it's level 100%. It just goes across the way. What it looks like as a whole underneath and how big it is underneath, I have no clue. The Earth could be a square underneath, it could be a cone underneath, it could be a circle underneath, it could just be round. I don't know. I think the Earth is a highly sophisticated machine. And the surface we live on is definitely a horizontal plane with high points and low points. Because we couldn't live on a globe. Why? Because how do people stick to the top and to the bottom at the same time?
They're saying gravity.
That's just a theory that can easily be debunked.
What do you think is inside the Earth?
Well, we only drilled 8 miles. Nobody knows what's inside the Earth.
So then where do they get the idea that there's molten?
It's someone's imagination. Someone smoked some crack and he just came up with all these theories. I'm sorry?
Well, lava.
Lava? Oh, I would say lava is created from high compression. You know, compression creates heat, right? So you have more compression, you have more heat. So I don't know exactly where lava comes from, but it would just come from simply the compression of the Earth the deeper you go down. Because that's one of the reasons why we can't drill past 8 miles, because it gets so hot. The further down you drill, because it becomes more dense. Because the further down you go, the more dense the Earth is, because there's more weight above it pushing it down. That's why their soil on top is very loose, but the further down you dig, the more compact the soil is, because there's more weight above pushing it out.
Explain these things.
So okay, so this is obviously a ball that's hanging, and when we accelerate it, the ball gets left behind, right? It swings back, right? That's because it's hanging. But with a buoyant object will always get pushed in the same direction as the applied force. So a ball in water will always get pushed in the same direction the water gets pushed as well. That's 100%. That's buoyancy. You've heard of buoyancy, right? So buoyancy is an effect of a force, and buoyancy always moves in the direction of the force. So the fact that buoyant objects get pushed up, that shows that there's a direct correlation with the Earth pushing objects up. Because when something's not connected to the Earth anymore and it's in free fall, that upwards push vanishes. That upwards push is only present when we're physically connected to the Earth. So force is only present when we're connected to the Earth, not in free fall. Even though they claim there is a force in free fall pulling you down, but that's made up. That's where they did the flip. So the Earth is literally moving up like an elevator, kind of, pretty much, but not in a perfectly straight line, obviously, in my opinion. But again, people could believe we are moving in a straight line through infinite space. It doesn't make a difference, you know. That simple fact that the Earth is moving up relative to us debunks the globe Earth. You know.
You think about Albert Einstein?
Albert Einstein, to me, it was just a public figure that was pushing the mainstream to push a narrative, just like they do nowadays with other characters, you know. So for certain, it's just the face, you know, in my opinion. He wasn't real, in my opinion. And he was bought out, 100%. Isaac Newton, that's another character, you know. He came up with laws of motion, which, again, there's some assumptions in there as well. It's like they knew that people were going to start talking about the upwards push of the Earth, so they had these laws established already, the laws of motion with Isaac Newton, which are, some of them are, you know, they're assumptions too. Some of those claims are assumptions. So, but again, they did that, in my opinion, because they knew that people were eventually going to start talking about the upwards push of the Earth. So yeah, it's in my opinion, it's the biggest lie on Earth, and it's the most censored because it's the easiest to prove. You know, a child can understand how a globe Earth is physically impossible. You know, the number one proof is the fact that gravity is pushing up. You know, the Earth is pushing up, not pulling it down.
I believe all things are possible.
Do you think humans can fly? Do you think it's possible? If you drink like some kind of potion and then you can fly?
I believe all things are possible.
You think that's possible? I don't think that's. Do you think it's possible to walk through walls?
I believe all things are possible.
Fair enough. I would say in a dream, all things are possible. Like if I'm having a dream in my sleep, then anything is possible. I could fly, I could walk through walls, I could breathe water. You think you could breathe water? I don't think you could ever breathe water. We'll drown. Do you accept physics as like a real thing, like cause and effect? Because physics is...
we've been defying the laws of physics, and I believe we can continue to do that.
I don't think we're defying the laws of physics. I think we're discovering new physics that we didn't understand before, if anything. Because physics is what it is. Physics cannot be broken. So a human being could never walk on water. A magician could because he's doing tricks. But in reality, a human can never walk on water. But yet people believe Jesus did, right? Because he's superhuman or whatever. But in reality, humans cannot walk on water. That's a fact. You know, humans cannot walk through walls. Humans cannot breathe water. Humans cannot fly. You know, we have limits. The human body has limits. You know, and that's physics. You know, you could, if you put too much weight on your arm or your bone, it's gonna break. There's limits. You know, your bones are not made of infinite strength. You know, our body, the physical world has limits. That's what I'm saying. The physical world has limits.
Interesting conversation.
No, I appreciate that, man. Appreciate that. All right, that was interesting for sure. Yeah, I noticed a lot of people will ask a question like why would they lie, right? Or what's the significance of this, right? Like, I mean, they both of the gentlemen asked me that on different occasions, and obviously that's irrelevant to the subject. But even when I give an answer, they're not really listening, you know, because I think they're asking that question either to buy time or in hopes that you're gonna say something that's just so far off to them that it's just gonna be enough to dismiss it, right? Like, I don't know what it is about, but obviously it's just it's crazy because again, when I start answering the question, it's like they're not really listening anyway, you know, or so. But again, the motive of a crime is a completely separate subject when it comes to establishing if there was even a crime. So if you're trying to establish a crime, right? Like if there was a crime, right? But you're trying to look for a motive without even establishing if there was a crime, what are you looking for? It doesn't make any sense. Because even if you did have a motive, a good enough motive for you, right? Before establishing the crime, like that doesn't make any sense because now you would have to make assumptions that because you have a motive of the crime, now that there is a crime. That's backwards. You have to establish that there is a crime first, then you can look for a motive. Because if you're looking for a motive before establishing a crime, that honestly doesn't make any fucking sense. You're looking for a motive for something that's not even real yet. You haven't even established if it was a crime yet, but yet you're looking for a motive for it. That's retarded. That's literally retarded. What happens first? You establish a crime. Okay, there is a crime here, 100%. Somebody got murdered. There's a dead body here with blood everywhere. There's a gun, right? First you establish there's a crime. Then you start looking for suspects, right? And then motives can help you who the suspect is. Now you're looking for a motive. What could be the motive for this? Oh, well, they owe money to someone, right? And somebody just come and kill them because they didn't pay them money, right? Now you can look for a motive because you established that there's a crime. So you have to establish the crime first, and then you can establish, a motive. And sometimes you don't even find a motive. This doesn't take from the crime. The crime still happened, even if you didn't find the motive. So that's why the motive is completely separate from the crime. When people can't even accept the crime, the facts that show that there's a crime, like, why would I even waste my time talking about a motive when you're dismissing the facts that shows there is a crime? talking about the motive is kind of irrelevant. You know what I'm saying? You know, again, a motive can help you find a reason why the crime happened, but that's it. It's just kind of like for peace of mind. Knowing the motive is just for peace of mind of the crime that happened. It doesn't prove whether the crime happened or not, even though literally people are using it as some kind of proof or disproof of the globe Earth, for example. It's like there's a way for people to dismiss it if you can't give me a good enough reason why they would lie to me. You know, when in reality, again, the motive is just so people have some kind of peace of mind after the crime was acknowledged. You know? I mean, that's crazy, but again, the mind does all these crazy things when it's like trying to defend a belief, right? I mean, we all kind of experienced that growing up as children. You know, I'm sure you had something at some time, you had a belief, and then you heard something that contradicted that belief, and I'm sure everybody has gone through this where you're kind of in denial, right? But again, that's just a personal issue at that point, you know? Sir Turtle Otter, I think that's kind of true. I don't believe there is a crime. Most are just doing what they were told, absent a rejected motive. So I think, obviously, at a certain point, it's like it's not a crime because people are willingly just being ignorant, right? But if you ask me, to gaslight children, to basically abuse children mentally, because that's what it is. You know, when you're lying to kids about this reality, you're abusing them mentally. So in my opinion, mental abuse, obviously, and physical abuse of children is a crime. So that's where I think it is a crime, you know, when we're telling this lie. Again, most people, like the teachers that tell it, are not necessarily committing a crime because they're kind of ignorantly just teaching what they were told. But in my opinion, there is still a crime there, you know. It's a crime on humanity at the end of the day. And there is a small group of people that are pushing this, you know. So there is a small group of people that are responsible for this crime, obviously, because it's not something that happened out of mistake. You know, they didn't just mess up. Like, oops, we made a mistake. The Earth is actually level, not a globe. Like, oops, like, right, that was not the case. So they're deliberately lying, and the people that are deliberately lying, especially to children, are committing a crime. You're psychologically abusing children, right? And I hate to say it, humans in general. Once you're an adult, it's no longer a crime because you're an adult. You know, you're responsible for your own being at that point. So if you're ignorantly buying into all these concepts of living, all these concepts about the earth and everything around you, if you're willingly buying into it, then it is no longer a crime, right? But the crime happened when we were very young, when we were children, you know, and our parents placed trust in authority, you know, and we place obviously trust in our parents and authority because obviously we're very young, we're impressionable, we're gonna look up to the adults for guidance, right? And that's where they get us, that's where they commit the crime, you know, because we don't grow up adults, you know, free, and then they introduce these concepts to us, and then we're able to make our own discernment based on that, based on what we've learned, and we're, you know, they're getting us when we're very young and telling us what to think and what to believe. You know, they're doing it very subtle, but it is forced. You know, but it's very subtle. You know, but again, it's people's ignorance and people's that, you know, that's fueling all that. You know, because if people weren't ignorant, if people were actually properly grounded, we wouldn't allow it. and the government would have to adapt. Like, people have to realize that the government was created by the people for the people. You know, people need to realize that government is not something that's separate. You know, they made it look that way. They make it look that way, like that the government is separate from us and we're supposed to obey and follow the rules and all of it. But guess what? The government is by the people for the people. So if the majority doesn't want to continue to do something, for example, then guess what? The government's gonna have to comply. You know. But again, it's about controlling the masses. That's how they're getting control of everything. You know. Because again, if the majority of people said, fuck no, we don't need a government, we're going to do everything local, we're going to form communities and gather all of our resources local, and we don't need government anymore, guess what? They don't want that. So they're going to manipulate people to not come together, and that's where all this division comes in, you know, from different countries and different states and different cities and all of this separation that's all in our minds. You know, and it's just there to keep us from coming together and actually building a strong foundation that's actually built on common sense, you know, and actually working towards resources directly, opposed to having 10 middlemen, you know, to just be able to get some water, to be able to get some resources, some food, right? We eliminate the 10 middlemen and we work directly towards that, you know. But yes, they don't want us to do that. They want us all crippled, dependent on the government, right? That's how they want us at the end of the day. That's how you control a population. You know, you can't control a population if everyone's independent and a critical thinker. Everyone's gonna be calling out all the bullshit all the time. People wouldn't stand for it. So this whole controlling of human beings is done through manipulation. It's to making you believe in things that are not true. It's the whole point is to make you throw away your common sense over an authority figure. And that's exactly how we're living. You know. Rom, it seems 90% of FE are stuck with immovable crap. Total dumbass BS. They also don't believe in space, though. In all models, we are surrounded by some space. I know, they're fucking stupid. Like, they mock, like, oh, you believe in outer space. Like, bro, Earth has to exist somewhere. Like, you believe it's just Earth, and then there's nothing outside of the Earth? Oh, but then you have these, I think it's to kind of feed the infinite Earth theory. There's no outer space, blah, 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 blah. The Earth is just infinite, right? But then it's like, okay, let's say, okay, the Earth is infinite, right? So is the Earth infinite going up too? Is it infinite, you know, going down too? Like digging through the Earth? Is it just infinite Earth downwards too? Obviously, that's a hypothetical, theoretical question. Obviously, you can't dig that deep, but if the Earth was infinite, technically the land extends outward infinitely in every direction, and technically it should extend down infinitely too. And then we have infinite sky above? Like, what? Because again, if you don't buy into this infinite Earth, which I don't, obviously, but like if you're thinking some kind of enclosed system, like some other motionless flat earthers would claim, then the Earth is enclosed, meaning it's enclosed because obviously there's something else outside of it. Why the hell will it be enclosed then? It wouldn't need to be enclosed, right? If there's nothing outside of the Earth or that exists outside of it, like, it doesn't make any sense. Obviously it's enclosed. If it's enclosed, it's because it's surrounded by another area, you know? So I don't know. It's motionless flat earthers. Yeah. Again, again, it's okay, they could believe all of that, but it's not backed by anything practical. Yeah, I'm thinking you must first have something before somewhere can exist. Yeah. You must have some place in order for something to exist, right? You need an area for something to exist within that area. So again, if you're a motionless flat earther and you accept that the earth is a creation, right? Well, guess what? The earth had to be created within an area. Right? Oh, guess what? It's God's workshop. It's outside of the earth. So that's what's outside of the earth. It's God's workshop. That's what it is. That's what the motionless flat earthers must believe in. I mean, again, it has to be something outside of the earth that created it. Like, it had to be created, in an area. But yeah. We're just a snow cone on God's shell. I was thinking, how some people think that the tides are like water rushing out and water rushing back in, right? Like, I was thinking, like, the earth is probably God's toilet, right? And he flushes twice a day. That's what we got, a high tide and a low tide. The earth is God's toilet. Oh my God. Prove me wrong that that's what the tides, are. Someone's flushing the water with a push of a button, the ocean waters, and then it's refilling back up again, just like your toilet. It's funny because I was thinking, what if it was an air bubble rising through space? Then someone else in our last live commented the same thing. Obviously can't claim shit, but food thought. Don't tell me what snow is then. Oh damn, that's what we all evolved from, right? God's white snow. It was all bacteria. They're just swimming. I think it's very possible that we are surrounded by water, I think that's very possible, that's for sure. Especially how the lights, appear to look, the stars, when you zoom into them. It literally looks like they're like rippling in water, like the reflection, that light, that we see, it looks like they're rippling in water. So yeah. That one, man. No, I had that. I literally somebody sent me an email, I think, about that postulation of us being an air bubble in water rising, and it's like, well, if that's the case, then that water that's outside of the earth, that's creating the upwards push to push the earth up, right? That has to be in motion too. So that water outside of the earth would have to be in motion to create that upwards push, to create the buoyant effect of pushing the entire Earth up, right? If the Earth was like an air bubble within water, then yeah, again, physically the water outside of that would have to also be moving. You know, so yeah, you know, that's where, in my opinion, that doesn't really make much sense, you know, in my opinion. But again, I don't. If there is water outside of the Earth, obviously, it's the Earth just moving through it. Maybe again, it's not a buoyant force that's pushing up the Earth. In my opinion, it could be something else. Again, like something mechanical, like a mechanical arm, a path, you know, and then the Earth isn't just moving through water. Again, being pushed by something else. You know, but it could also, you know, it could still be moving through water, but it doesn't necessarily need to be buoyant, you know, to be able to move through water, you know, so yeah, it's a damn chicken and egg thing, yeah. With the well, it's kind of like this reality, huh? Like, if space is not infinite, well then it's like, that's where it's like kind of leads you to infinite space, because okay, this is physical, right? And there's an area outside of this space, right? Okay, well, how far does that area go? Is that area infinite, or is that area enclosed as well? Because if that area is enclosed as well, well then what's outside of that enclosement? Another area? And how far does that area extend? You know, so again, you could just have an infinite regression of like, well, where does the universe end? Where does reality, the physical, end, right? You know, and if there is an end, how does that end look? How would it even look like the end of space? Right? I couldn't even conceptualize anything. You know, when I think of an end, I can only think of like, because you can't just say, oh, it's just blackness. But that's the thing, if you could still move through the blackness, there's still space there. So blackness alone wouldn't necessarily suggest an end of the physical, because you're physical, and if you're still moving through it, it's like, it's crazy. It's crazy. It's pretty crazy to think about. Come on, man. One more conversation. Come on. It does seem infinite in all cases. You hit a wall, what's beyond the wall? Surely it can be infinite containment. No, yeah, that's why I don't dismiss infinite space. I don't dismiss it. But again, I can't prove it either, you know? But for the same reason that I can't prove what's outside of the Earth, I can't dismiss it either, you know? What's up, John? Because yeah, you come to that dilemma. It's like, if there is a barrier, right? What's beyond the barrier? More space, and then, you know, you eventually reach another barrier, or what? Or, yeah, it's pretty crazy, pretty bizarre. It's a little windy. Oh, my shit, I tip over. Yeah, that seems to be like the number one go-to for people. Again, it's the lights in the sky, you know. I've noticed that before I started doing the buoyancy and force presentation to debunk gravity, before I started doing that and I would ask people why they believe the Earth was a globe, the number one answer was usually gravity. You know, gravity. Oh, the pulling force of gravity. You know, that's why I believe the Earth is a ball, because in space, you know, this force creates spheres because it's a pull, right? Everything gets pulled to a point, and then that creates a sphere, right? I'm assuming that's where that comes from. But now that I start off the presentation, obviously showing how gravity is just theory, a pulling force, and the actual force of the Earth is up, you know, a push. Almost nobody says gravity anymore. That's their number one proof. Most people just jump to assumptions about the stars, the sun, and the moon, and images of the Earth from space. Those are the two number one proofs I guess people have, other than the gravity one, because obviously the gravity one, once we establish what force and what's required for force and buoyancy, then it kind of shatters that proof, you know, off the bat, you know. But yeah,
I'm glad.
that seems to be where the conversation goes usually, you know. And I'm always gonna try to pull it back, because I do entertain the stars a little bit too much, a little bit more than I should, because again, it's completely irrelevant. Nobody knows what they are, you know. It's a waste of time, you know. Let's be real, you know, talking about these stars when we want to establish the shape of the Earth. It is a waste of time. But again, people have this idea that somehow looking at the stars and making assumptions about the stars proves the shape of the Earth. Again, an assumption never, ever, ever, ever proved anything. That's why it's an assumption. So to use assumptions about other things to try and prove something else is just completely illogical. It's just not gonna work. I know, that's true, Ram. They mock, oh, gravity is a strong enough force to hold the oceans, the trillions and trillions of tons of oceans to the Earth, but it can't hold the butterfly, you know, or same thing with the motionless flat Earth. Electrostatics, right? It creates this force, or the weight, or whatever, and this force is able to, you know, hold the entire trillions of tons of ocean water down, but a butterfly can easily fly, right? It's like they don't realize, like, they're literally mocking themselves. Like when they mock claims of gravity like that, and you're a motionless flat earther, you're literally mocking yourself. Like, motionless flat earthers have no place talking about gravity or trying to debunk gravity. They literally have no place in that conversation whatsoever. You're gonna look fucking stupid as fuck because you're literally claiming the exact same thing. And that's why you don't see a lot of motionless flat earthers talk about gravity as much. You know, what do they talk about? Oh, observations of Polaris and observations with my you know, P1000, you know, and that's proof. You know, observations alone are proof enough, right? That's what they focus on. So again, all these motionless flat earthers trying to mock gravity, you look like a fool. You look like an idiot. You know? Hate to break it to you. You're better off just not even talking about gravity. I used to stay away from the conversation myself. You know, before. I wouldn't talk about gravity. And I wouldn't talk about what the cause is for objects that accelerate down. I just claimed that it was irrelevant. Obviously, I was wrong. But I just didn't talk about it. So my best advice to these motionless flat earthers, if there's anyone watching, is stop talking about gravity. You're gonna make yourself look fucking stupid. You know, you're only gonna be hurting the cause. You're not gonna be helping us. You know, you're gonna be giving fuel to these fucking globe earth troll channels now. That's all that happens. Is a motionless flat earther says something stupid about gravity and what gravity actually is. Then you have this globe earth troll that somehow has a lot of subscribers and views mocking this flat earth and making stupid ass claims. And now the people that watch this globe earth troll think that that's what all flat earthers think now. You know, and now they have a fucking preconceived idea of what a flat earther is and what flat earthers believe, right? So all these fucking morons, all these motionless flat earthers making claims about what gravity is and why objects go down, again, you're just giving fuel to all these other fucking channels that are just mocking the shit out of you. All these globe earth channels that are just mocking you. You know? Because that's all they have. The globe earth just has theories, concepts, and ridicule. Those are their three main points of argumentation. Theories, assumptions, and fucking just bullying, just talking shit. They just try to mock, you know. Fred, this discussion is on another level. I would say it is. The discussion about the true nature of the earth, about, you know, about what the earth actually is definitely on another level. Most people are lost. Constant upward vector force. Yep. Yep. Mate, did you see David A. Young, Goodbye to Gravity? LOL, Effie loved it. We all mocked it. Nah, haven't seen that. Come on, come on.
Yes, I am.
I'm gonna switch the battery on this camera real quick, and then I'm gonna wait like another 15 minutes or so, 15-20 minutes, and then hopefully we get one more conversation. Shit. There we go. Yeah, I'm switching the battery just in case we do get another conversation. That way I could get the entire conversation on my second camera. I'm usually lazy to do this part. That's why I usually like skip it. But might as well just do it. So back on, full battery. Just joined William. Any thoughts on the Artemis thing? Do you think it will bring about more people questioning the space program? I have no comment on that. Ah, come on, man. Cal40H realm. I admit I found upward vector as really crazy for 2 months and looked it over about 20 experiments. Engine got blocked. Yeah, conversations are always kind of slow right here, I noticed. Bummer. Be aggressive with them. What's crazy is that like a lot of people are not even making eye contact. They're not even like looking at the table. Usually when they're like looking at the table, you know, I look at them, and then if they make eye contact, I usually invite them over. But people are avoiding like eye contact. They just look at the table real quick and then turn right when you see me like look up or something. Salesman tactics for market, I know. That's where like the incentives could come in, like having like a $10 challenge, right, or something like that. But I don't have money like that to just be giving away. It actually costs me money to come out here, you know. I don't have more money to give away like that. Ever thought of writing a book? No. Hell no. Never even crossed my mind, you know, to write a book. Yeah, I was never a big fan of books growing up. Even now, like I'm not a big fan of reading and books and stuff like that. Doesn't really interest me. So by default, you know, writing a book is like I don't remember the last time I read a book, like a actual book. Like, yeah, no, reading was never my thing. I was always a visual learner. I always liked to see things practically. And even today, like when I do any research, I usually like to see a video of what I'm actually researching opposed to just instructions. Like I could follow instructions, you know, but I prefer a visual demonstration. You know, like when I'm working on my car, for example, and I need help. Oh, how do I do this? You know, I don't just read what I'm supposed to do, even though I do read, but I like to see it as well. I look up a video of someone else that already did what I did, and usually someone already made a video about everything when it comes to cars, and, you know, how to change parts in cars, and you know, so the point being, you'll find a video if you look for it, and visually seeing like what to do is way better for me than just reading what to do, you know. Yeah, not only because I don't really like reading, but it's just more self-explanatory when you actually see it, you know. So that's just me. Man, oh well. We 5-10 more minutes. Come on. God damn it. Yeah, the first conversation I had, it was going good. It was cool and everything. I think the other guy that jumped in kind of threw off the conversation a bit, you know, because, you know, we're going back and forth, and it was cool. You know, we're kind of staying on topic for the most part. And when the other guy chimed in, they started talking about the shadows on the moon and how the sun and the moon are not what we were told, which, again, it was basically what I was saying already, you know, and it's irrelevant to the shape of the earth, but kind of threw off the conversation a bit, went off topic, and the other guy just left, the guy I was first talking to. And then the second guy that kind of like chimed in after, like it looked like he was interested, but then he wasn't giving anything back really. Like he was just trying to like ask me questions, as in like, oh, why do you believe this, or what's your hypothesis, and why is this important? Like, right? He was just basically asking me questions. So when I would ask him questions, as in like, you know, if you believe the Earth is a ball, why do you believe the Earth is a ball, right? Hi.
I don't really want to be filmed, but I was just curious like what you're doing.
Oh, here, if you don't want to be filmed, I can give you my flyer. You can check it out. I'm live streaming right now too. So
Oh, okay, sorry.
yeah,
Didn't
no
mean
worries.
to interrupt.
No.
Okay,
Go ahead. Yeah. Yeah, there's just another table right here that they're giving out free drinks. I guess they were curious. So we'll see. We'll see if they come and ask any questions. What's up, man? You want to give us a shot real quick?
Sure.
All
I've
right.
never done one of these.
All right, there you go. It'll be your first time. All right, so two very easy multiple choice questions. So
Okay.
this is the first one. So we
Yes.
have 3 box trucks. They're completely sealed. They're all on a level surface, and
Yeah.
they all have an apple hanging from a string.
Okay.
The only difference between these 3 box trucks is that one is at rest, one is accelerating forward, and one is accelerating in reverse. So out of these 3, which one is at rest?
At rest.
At rest.
This one.
Yes. Why would you say B?
Sorry?
Why would you say B?
Because like things that are in a body in motion kind of want to stay like consistent with that body in motion.
Okay.
Versus like if I were to slam on the brakes, like that would be the case.
Okay.
If I were to accelerate really fast, like that would be the case. But if I'm like at a consistent acceleration, it's probably
Well, what about if it was just parked? Like
Just
it was,
parked?
Yeah, just at
Yeah,
rest.
same.
Same thing, right?
Yeah.
And it's because there's no motion.
Yeah,
of
yeah,
the
exactly.
apple, right? Exactly. Okay, which one's accelerating forward? What truck is accelerating forward?
like the acceleration.
Yeah.
is, okay. A.
Yes,
Yeah.
A is accelerating forward. How did you know A is accelerating forward?
Because the apple's going backwards.
Yes. And then I can show that here. Look, this ball is swinging. It's hanging. Like
Yeah.
when I accelerate it this way, the ball gets left behind.
Yeah.
You know, because of
That's the
inertia.
resistance change in
Yeah,
motion,
yeah,
yeah.
the resistance change in motion because of inertia. Exactly. You got it. The first one. Second, same thing,
For a balloon.
but it's a helium balloon inside now. That's the only difference. So
Yeah.
out of these 3, which one is at rest?
This one's at rest. This one's accelerating backward. That one's accelerating forward.
So you think this one's accelerating forward?
Yeah.
Okay, so I'm gonna show you this real quick. So this ball in here,
Uh-huh.
it represents the balloon because it's buoyant.
Yeah.
So it's floating just like the balloon is floating in air, right?
Uh-huh.
But this is water. But it's the same effect. It's just, it represents it. So I want you to pay attention when I accelerate it from being at rest to
Yeah.
see what happens to the ball. Did you see what happened?
Yeah.
So going back to this question, which one's accelerating forward? You want to see it again?
Yeah, I mean, I still think it's A.
You still think it's A?
I mean, it's going to be varying because, like, it has a stronger desire.
Well,
kind of the same desire to stay.
this represents the balloon because they're both buoyant. Would you agree that the helium balloon and this ball in water, they're both floating, right?
Yeah, relatively.
Yeah, they're both floating, right? I would say they are, obviously. They're both, the strings
I
attached
think
to the bottom.
the difference just comes with, like, the amount of friction that's, like, on the ball.
Right, but my point is that when it's at rest
Yeah.
and I accelerate, what direction does the ball go?
More closer to C.
Yeah, it is
Yeah.
C. So the correct answer is C. C is accelerating forward. Because you cannot accelerate forward and a buoyant object go backwards. That will never happen. That will happen with something that's heavier than air, that's like a rock or an
Yeah.
apple or this ball.
Yeah.
It will get left behind. With a buoyant object, the buoyant object will never get left behind. It will always get pushed because the medium that surrounds it is more dense.
That's cool.
So it's able to push it along with it.
That's cool.
Right? So that's buoyancy.
Yeah,
So
yeah.
here, I did this experiment in a cargo van, and it's basically both questions
Okay,
in
wait.
one.
I'm curious though.
Yes.
What are I was expecting like trivia questions that compares me to a fifth grade.
No, well, this is just basic elementary physics.
Darn it, I want like geography, like trivia.
We'll
questions.
get there. Look, yeah.
Rodriguez is lost and found it.
So here.
Lost and found.
Sure. I'm actually not sure. Maybe it might be somewhere in the middle.
I don't know if you want to give this a shot, but look, I recreated this experiment. They're both questions in one. So there's an apple. I don't know if you guys can see an apple and then a helium balloon inside. So what direction?
that's cool.
Yeah, what direction did I accelerate? This to the right, to the left, or is it at rest?
Yeah, that's cool.
I accelerated this way, exactly, because that's the direction the balloon got pushed, and the apple only got left behind. So here's a bonus question.
I remember learning about King George in fifth grade, not buoyancy.
Well, we should be learning about this, in my opinion.
yeah.
But here's the thing.
Yeah, that was fifth grade.
So here's the thing. It looks like the apple and the helium balloon are moving away from each other, right?
Yeah.
It looks like they're moving away from each other, but the reality is only one of those has true motion, and the other one has apparent motion. So only one is truly moving through space. So out of the helium balloon and the apple, which one? Yes, the balloon.
That was just inconsistent.
Yes. So the apple has apparent motion. Everything else has true motion. The air, the car, and the balloon. Yes. So here's one last question before you guys go. If I have a helium balloon here on Earth and I release it, what direction does it go?
Helium?
Yes.
Up.
Why does it go up? There's two reasons.
Because it's less dense than the air.
Yes, that's the first reason. What's the second reason? The second reason determines the direction the balloon gets pushed, because obviously it doesn't get pushed left, right, or down. It gets pushed up. Why does the air push it up?
The air that is above is like replacing it.
Okay, so we understand that
Yeah.
helium, a balloon cannot push itself, right?
So yeah, so like
So it's the air pushing up the helium. Would you agree?
yeah.
So we know air cannot push itself either. The air requires something else to push it. So what's pushing the air to be able to push up the helium?
Gravity.
It is gravity, but here's the thing. Gravity as a pulling force has never been proven or detected. That's why it's just a theory. The fact is the force of the earth is a push. So right now, you're not being pulled down to the earth. It's the earth literally pushing up against you. And
Well, they have a equal and opposite.
so they talk about the normal force, right?
Yeah.
So the normal force is the only real force that can be measured and detected with actual instruments here on Earth. When you're not connected to the Earth, for example, things only appear to go down because there is only an apparent motion. Just like the apple being left behind, when you release a dense object here on Earth, it's just being left behind. It's because the entire Earth and everything that's connected to it is moving up. So this never moves down through space. It's the Earth that's moving up to catch it up.
Well, I don't think it, because that just comes down to the human concept of like what is down.
Yeah, well, down, I would say it's the opposite direction of the force of the Earth. Up is the direction of the force of the Earth.
Yeah, but
That's
like
because a helium balloon will always get pushed in the direction of
I
force.
disagree because I think whatever is the larger mass is the item that is pulling it.
So you're believing in this pulling force of gravity,
Yeah.
right? So when I release this object, you believe that there's some kind of flow that
Well,
pulls this
I
down.
know that this is pulling up on the Earth, but the Earth is much
But here's the thing.
than this.
Yeah, obviously. That's
Yeah.
the theory of gravity. Mass attracts mass. But that theory has never been proven physically. That's
I
my
mean,
point.
it's a scientific theory.
Yeah.
Theory is as good as it gets.
Well, here's the thing, though. If you guys look up the normal force, because buoyancy, you guys should look
Yeah.
up what buoyancy. Buoyancy is a push. It's
Yeah.
an upwards push. So that upwards push is only there when you're connected to the Earth. So the upwards push, again, so this buoyant object only gets pushed when it's physically connected to the Earth. When it's not, when it's in free fall, that upwards push is no longer there. So that shows that there is a direct correlation of buoyant objects being pushed up when they're connected to the Earth, because it's the Earth that's giving us that upwards push. So that, again, what does that mean, right? You guys believe the Earth is a ball, right?
Yeah.
So you guys understand that on a ball, up is relative? So if you're standing here, up is this way.
Yeah.
Up is in every direction away from
Yeah,
the
to the point of what is down.
Yes.
Yeah.
So if we could prove physically that the force of the Earth is actually a push and not a pull, and buoyancy shows us that, how can the Earth push up in every direction at the same time if it was a ball?
Well, I guess one theory is that it could be like somehow constantly expanding without actually gaining
Expanding?
mass.
Yeah. So that's what they say.
So
but
weird space,
yeah. So
weird things probably are happening.
okay, fair enough. But yeah, the Earth would have to be expanding, which in reality,
I don't think it's
not.
Also,
Obviously.
like for example, like the moon, right? Like at the equator, elevation or altitude is much higher than it is other places because the moon has some sort of gravitational exertion like on the Earth. Even though it's much smaller than the Earth. So even though Earth keeps the moon by us, the moon still exerts a force on it. So I don't think it's the Earth going up in any way.
Okay.
I think it's just purely like.
So how does the air push up the helium without the air being physically moved up
Well,
as well?
it's the theory of just like it has to be this or that, essentially. Like, which one's denser? Which one does the Earth want to, like, kind of pull on more? It's the item that's more dense.
Let me ask you this. Would you guys agree that a helium balloon gets pushed by the air?
Yes.
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 Okay. We can all agree too that air cannot push itself.
It's being pushed because
Isn't air pressure just air pushing itself?
Well, how do you create air pressure? How do you increase air pressure?
Well, I mean, it's
more heat or more.
You add more
molecules.
force.
Well, in this case, I think it's the fact that
Yeah, increase air pressure. So a buoyant effect, for example, will have a rate of motion up, right? A buoyant object. If you have a long tube and there's a buoyant object increasing, and you increase that upwards motion, that buoyant object will go up even faster because you're adding to the upwards pusher. Right?
Yeah.
So everything's moving up through space right now, but it seems like it's motionless because we're within it.
yes.
So it's like
But
when I
here's
release
the
this,
thing, it's like when
the
you
Earth is like
ask
an
me-
elevator that catches up to this.
When you ask me
So
which
that's-
is the one that's
yes.
truly moving, you said it's the balloon, right?
Yes.
And which one's not moving? It's
The apple.
The apple.
Yes.
Because that was the one where it was the gravity,
Yes.
not the buoyancy. So I think in this case, what is the truer force in this sense is the gravity, and like specifically helium is number 2 on the periodic table, much less dense than the 70%.
But here's the
nitrogen,
thing.
21%
But here's the thing. The
oxygen.
gravity is
Yeah.
only affecting the buoyant objects because gravity. You're claiming gravity is a force, right?
No. So what it is it's pulling down more so on the other particles than it is on that particle essentially. So as it moves up, you have this vacuum of space underneath it, and all these air particles just want to rush to fill that space because it's a vacuum. Sure. And then that kind of like how an airplane flies,
Sure.
creating that vacuum space underneath the wing, so those air molecules want to rush underneath.
So all of this is based on the assumption that you believe there's a pulling force,
Yes.
pulling things down. Okay, if there was an experiment, so everybody's cell phone, smartphone,
Yeah.
has a built-in accelerometer. What that means is that it can detect when you have it in portrait, and then when you change it to landscape, it
Yeah.
detects the vertical force of the
It's a
Earth.
gyroscope, no?
Gyroscope.
Accelerometer is used to be gyroscope position.
Gyroscope detects a change in position.
Yeah, so
But what I'm getting to is the accelerometer also detects the presence of a force. So if you download an accelerometer app and you open it, you can detect the presence of a force, and then when the phone is at rest and you accelerate it or move it in any direction from being at rest, it's going to detect an increase in force.
Yeah, but as opposed to landscape or vertical, that's the gyroscope. This is the accelerometer.
Well, the accelerometer detects the force of the Earth, and based on how you position your phone, that's how it reads it. So a gyroscope can help that as well.
Yeah.
But my point is that when I download an accelerometer app, here I can show you. I did this experiment. It's only a minute long. You guys can see it.
Okay, wait.
So this is how we prove that there is no downward
Okay,
force.
I have a meeting at 1:20, but I really
Okay.
like what you're teaching me. So what should I take away from this?
Okay, so that's where I was
one
getting
thing I should
to.
learn.
So buoyancy, again, you can't have buoyancy without a force. Buoyancy is an effect of a force. And a buoyant object will always get pushed in the same direction that the medium that surrounds it is also being pushed.
Okay.
That can recreate that 100% of the time.
Okay.
This thing doesn't get pushed because it has inertia. The air is not dense enough to push it. So the inertia of the ball is stronger than the push of the air. Because the inertia of this ball is not strong enough, so it gets pushed with it. So there's a force acting on the buoyant object in the same direction that the water or air is being pushed, right?
Yeah.
So when I let go of a helium balloon here on Earth and it shows me that it's being pushed up by the air, that shows me that the air is also being pushed up. What's pushing up the air? It's the literal ground underneath your feet that's pushing up the air, that's pushing up helium. What does that mean? Well, that means that if you believe in the globe Earth, and you believe up is relative, the only way for Earth to be able to push up, if it was a ball, is for it to be expanding in every direction. But that would mean the Earth would just explode. So that wouldn't work. So the only reason why people believe the Earth is a ball is because people believe in the theory of gravity being a pull. Because if we could prove that it's actually a push...
So is this
Is there even a this push versus pull dichotomy even well-defined?
Yeah.
What's the...
So you could look up the normal force. That's the upward push of the Earth. That's
So that normal force is a push.
It's a push, yes. The
Why-
pulling forces don't exist. So the mechanism of a pull of a force doesn't exist. Everything's applied pressure.
What is the definition of a push or a pull?
Well, push is something pressing against something else.
Okay.
So something that has mass pushing against something else that has mass.
I-
So when gravity came to push this down or pull
Here's
it
the
down,
thing. I think the problem also comes in the difference in the word down and up. I don't think there is down and up. I think it's literally just
well, on a
mass,
globe Earth, up.
how much mass it is and how much they want to pull on each other and how much they push it.
Well, on a globe Earth, up is relative. I would agree. There's no up or down on a ball.
So is this
But here's
flat Earth thing?
no flat Earth. No. So
Okay,
here's the
okay,
thing.
cool.
It's close, but it's not flat Earth.
Okay.
So so in order for people to believe in the ball, you first have to believe in gravity being a pull, even though it's just a theory. It has never been proven, admittedly so.
Okay.
And that's because the real force is a push. What does that mean? That means if the Earth is pushing up, that wouldn't work from a globe because it just explode. If it's expanding, pushing up and everything, the fact is the Earth is just an extended level plane that's pushing up in one direction. So everybody's up is the same. So people in Australia are not underneath your feet, and people in
Like
China are not
perception-wise, for the size we are, like, yeah, we don't perceive it that way. Yeah. But okay,
I mean,
thank you so much.
No worries,
This
man.
was really cool. I was surprised by this one.
No, yeah, again, that debunks gravity. That simple observation of buoyancy. Buoyancy does. Buoyancy debunks gravity easily. Because if gravity is strong enough to pull all the buildings and keep all the buildings down, how come it can't pull down the helium balloon?
Well, it pulls. I mean, the air pressure. It can't like.
So the air, so
if
gravity.
I put this here, the table is strong enough to resist the force. Of
No, I'm asking why, if the force of the Earth is so strong that it can hold the trillions and trillions of tons of water to the ocean, or the oceans to the ball, if it's that strong, how can a helium balloon rise?
Well, the air pressure is strong enough. The air pressure should be strong enough so that the air pressure pushing everything away from it is stronger than the gravity of the helium balloon.
So let me ask you this: do you think air right here on Earth right now, do you think it's being pulled down towards the Earth, or do you think it's being pushed up?
Well,
The air,
the net force of air would be zero.
So it's not moving at all; it's just static.
Relative to the Earth, yeah.
So it's static relative to the Earth. So how
Well,
can?
I mean, no, it's windy, but like presuming.
Sure, no, yeah, but I get what you mean. So that's like claiming that I can make the water push this ball in this direction without actually moving the water in this direction.
You're saying you could make the
No,
water.
no, that's what you're claiming. You're claiming that the air here is not being pushed up, but somehow air is able to push a helium balloon up, even though the air is not being pushed up. That doesn't make any sense because that would mean that you can push that.
No, I mean air. I mean every like I don't know the exact numbers, but I think like there's a force of like an elephant or something on our shoulders due to air pressure.
Yeah, we do
So-
have some weight on us from air
Yeah,
pressure.
so
I agree.
there's a lot of force due to air pressure, and if we are, yeah, I guess if we're in if we're somehow like in the air, the net force due to air pressure should be. I guess it should be zero.
So here, like just real quick, in physics, in order to create or increase air pressure, or to recreate air pressure, you need a container that's, for example, if you want to create pressure with air or increase, you have to accelerate or apply force to that container. In other words, move it, accelerate it, in order to increase the pressure inside or to create pressure inside.
Well, I mean,
That's the only
static tank of air still has air pressure.
Yes, because it's connected to the Earth. If you put it in free fall and it's not connected to the Earth, it no longer has pressure.
If the container is fixed, then it would.
So, because we have a pressure gradient here on Earth, right? You have more
Yeah.
pressure on here, and then the higher you elevate, there's less air pressure. So the only way to recreate those effects is to have a container in motion. So the Earth is literally the container that's in upwards motion, and that's how you recreate density layers
I don't
in a
know.
particular
No,
direction.
if I have a box,
Yes.
let's say this
Yes.
box without the ping pong,
Yeah.
and it's perfectly sealed, and I put it in a vacuum,
Okay.
there would be air there would be air pressure.
Oh yeah, that's because obviously we're within Earth.
Wait, sorry, can I ask?
Sure.
Sorry.
No, no worries. So yeah, basically the only way to recreate air pressure, like in a different direction, for example, because obviously we have a vertical vector here, right? And we experience motion vector of balloons rising and things falling, right?
Yeah.
We experience a motion vector here, vertical. In order to recreate this motion vector we experience here on Earth, we need a container that's in motion. So when I showed with the cargo van, we seen that there was a vertical vector because the balloon wanted to go straight up and then the apple wanted to go straight down, right?
So you're saying there's a motion vector?
Yes, so by moving that container in a different direction rather than its resting place, we can change the vector. Because then the balloon goes forward and then the apple gets left behind. Now we change the vector diagonal. Now the vector is diagonal because we added a horizontal force. So horizontal force, which is motion of matter, is what creates the vector we experience here on Earth. So you need matter to be in motion. So you believe
to have force,
to have force, and to have force, and to have pressure, and to have pressure too.
Well,
because the air pressure, when I accelerate this, it's the water pressure that shifts to the back that pushes this forward.
I don't agree that you need a force
to create air pressure.
I don't agree that you need motion to create a force.
Yes.
You need motion to create a net force, but I don't think you need motion to create a force.
Well, the literal definition, I mean, it says acceleration, but F equals ma.
That's net force equals mass times acceleration.
Yeah, so you need matter to be in motion.
Well, for net force, I think we agree on that. But
okay.
For non-net, like just a force, like air pressure, for example.
Well, for example, to create buoyancy,
for example, this on the table. There's force of gravity and the force of the normal force, but there's no motion in this. When you're not moving this at all, there's no motion, but there's still force.
But if I cut this wants to be pushed up right now. So there is a motion up right now. Because this is pulling the string up right now.
Okay, I'm just saying like like my phone, for example.
Yeah.
There's clearly gravity's pushing it down. Clearly the normal force is pushing it up. And I guess could we agree that my phone is not in motion right now?
I would say it's at rest, but something can be at rest and still moving through space.
Well, with respect to the reference frame of the
yes.
Earth, would you agree that my phone is not in motion?
It's not in motion relative to the Earth. Relative to the Earth, but in physical reality, it is moving with the Earth altogether.
Well, I mean, motion's only well defined if you have a reference frame.
Sure, and the reference frame is the Earth. That's what gives us our direction.
Then, therefore, given that reference frame, motion is. This phone has no motion, even though it has force.
Sure, visually it has no motion. Physically it does. How do we know that? Because physics shows us that a helium balloon will rise because it's being pushed.
This phone, I'm saying so.
Okay, look, I'll show you. So I have this experiment I was going to show it earlier.
Correct me if I'm
So real quick, here.
A digital accelerometer is a device that detects the presence of a force or acceleration. For example, when at rest and connected to the Earth, it detects 1 g-force. As soon as I accelerated from being at rest, the accelerometer detects that acceleration by increasing the g-force. Whether I accelerated to the right, to the left, up, or down, the accelerometer will always detect the acceleration 100% of the time. However, the instant I put the accelerometer into freefall, it detects a deceleration. It goes from 1 g down to 0. If the accelerometer was accelerating down in freefall, it would detect that acceleration by increasing from 1g, not decreasing. Not only does the accelerometer show that there's no detectable acceleration in freefall, it also shows that the vector of force of the Earth is up.
Well, so this g-force is the normal force, but I think.
But look, this is very key. Let me see, hopefully this goes away. Yeah, look at the vector. That little green line is the vector.
Of the normal force?
Of the normal force.
Sure. And then it's 0 when you drop it?
Apply a force up, the downwards vector increases, showing that the vector on the phone is inverted from the true direction of the force.
Well, that's just showing when you drop it, there's 0 normal force. But
there's 0 force.
Well, there's gravitational force.
There is no gravitational force. So let me ask you this. So just before you go, like applied pressure.
I do need to go.
No, but just real before you go. So pressure is the only thing that can cause matter to move. So something pushing it. Okay. Tell me a mechanism that's not pressure that can make something move.
The electromagnetic force.
Okay, electromagnetic force. First of all, magnets, nobody has 100% understanding of how they work, but there's been a lot of tests to show that there is some kind of flow of magnetic field that pushes metal objects. So there is a flow of direction of something pushing on metal objects. So that's still a push. My point is, what's the mechanism of a pull force that without applied pressure?
I mean, I still don't understand, like, rigorously. Like, I get, like, okay, I'm pushing, I'm pulling. But rigorously, I don't understand what the formal definition of a push and a pull is. So I feel like if we're going in this level of detail, I can't appropriately answer.
I'll answer that real quick and very simple. The difference between push and pull is just, so for example, push is an actual force. push is a force. Obviously, you won't deny that, right?
Sure.
Push is a force. It's something that something that presses on against something else. That's a push. Right?
Yeah, I don't.
Okay.
I don't even know if that's what the fuck.
Okay. You want like a college level? I'm giving you the elementary definition that a child can understand, which is a push. Something pushing on something else. Right. I can make it more complicated, but that's pointless. Pull. When it comes to something being pulled, it's still applied pressure. Pull is just a description of direction. So, for example, when you open a door, right? When you pull a door open, you're still grabbing the handle and you're still applying pressure. But we say pull because the door is coming towards you. So, pull is only being used as to describe direction.
So it's like the direction of attracting the thing that's exerting the force. The thing.
Pull
like,
is
I'm
just a
exerting
description
force
of
on
direction.
This, it's going towards me if it's a pull. And
Yes. Yes.
What if it's
but
going perpendicular?
It's still a push, but you're just pushing it sideways. But when we bring it towards us, we say pull. But you're still pushing it towards you.
So in that case, then I feel like the word push almost is meaningless because you're saying
no, the word pull is meaningless.
Well, either
pull doesn't exist.
You're saying push is the same as a force, which means that I'll just use the word force and say.
Sure, but that's the thing. Though, what is force? If I was to ask you, you're gonna say pull and a push, and it's not. It's just a push.
What would I say? Force is? Well, I guess I know net force is mass times acceleration.
What's a force?
Force is something that could be measured in newtons.
Okay, I'm a 10-year-old. Simplify. What is force?
Oh, well, okay. To a 10-year-old, I'd say it's a push.
Exactly. Would you say it's a pull too?
Yeah.
Okay. What's the difference between push and pull?
I could say a pull is a type of push.
The mechanism of a pull. What
I
is it?
really need to go.
No, yeah. But just know that the mechanism of pulling force doesn't exist. It's just imaginary. So when you release an object, you believe that there is some magical force behind the air, that's accelerating this down, which has never been measured or detected. Maybe. Yeah. Well, yeah. Fair enough. All right, man. Take care, man. Whew. All right, that's gonna be it for this one. Oh man, you wanted to?
I don't know what's going on. Can you tell me what's going on?
I'll do this for you one more time, real quick, because I don't want to just rush into it. But
Yeah.
okay, 3 very easy questions.
Yeah.
3 box trucks completely sealed on a level surface. They all have an apple hanging from a string, right? The only difference is one is at rest, one is accelerating forward, and one is accelerating in reverse. So out of these 3, which one is at rest?
Which one is what?
Which one is at rest?
At rest? I mean, I was overhearing your conversation, but I mean, I feel like intuitively it would be this one, but it would be these 2.
You think these 2 are at rest? That truck? Because obviously one truck is accelerating forward, one is accelerating in reverse, and one is at rest. In other words, it's not moving.
It's a simple question.
Yeah, simple.
B.
Yeah, it is B. It's B. Or complicated. Well, why would you say B though?
Huh?
What's the simple answer? Why B?
It's not, nothing's moving, it's not swinging.
It's not swinging.
Yeah.
Exactly. Pretty simple. Okay, which one's accelerating forward? Yeah, the truck. Yeah, the truck. How did you know this one's accelerating forward? Right. Yeah, because the apple's being left behind because everything else is moving forward. Like this represents that, and if I accelerate this way, it gets left behind and then it crashes into it, right?
Correct.
Due to inertia, it just remains in its position. Right. Perfect. So this is the second one. Very easy.
Yeah.
Instead of an apple, it's a helium balloon now. That's the only difference.
Okay.
So out of these 3, which one is at rest? Yes, for the same reason as the first. There's no motion of the balloon.
Yeah.
Which one's accelerating forward?
Inverse, so maybe this one.
Okay, you actually got it, but how did you know it was that one?
Because, like, the other one was hanging down from the top.
Yes.
So it's just the inverse.
So you just went inverted.
Yeah.
Okay, that was actually a pretty good guess. It is this one. So there is 2 reasons why it's this one.
Okay.
Do you happen to know why it's this one? Like why the balloon goes forward when you accelerate forward?
Besides the fact that it's hanging from the bottom. I don't. Now that I think about it, I don't know.
Oh, yeah, I'll tell you why. There is 2 reasons. So the first reason is obviously air is more dense than helium.
Okay.
So that's the first reason. The second one is a force. So as soon as I apply the force in this direction, all of the air that's in the truck is also being forced in that same direction through space. And because air is more dense than helium, is able to push it along with it.
Okay.
So again, it could do it with water and air as well.
Okay.
Water's more dense than this ball, and when I accelerate this way, the ball gets pushed along with it.
Right.
So a buoyant object will always get pushed in the same direction as the force.
I'm not STEM or anything. You have to define buoyancy for me.
So buoyancy, you ever had like a ball that floats in water?
Right.
So when you put it underneath the pool and then you let it go, it gets pushed up.
Yeah.
That's a buoyant effect.
Okay.
So a buoyant object will always get pushed up here on Earth,
Okay.
right?
Gotcha.
And a buoyant object here will always get pushed in the direction of the force too. You know, the ball will always get pushed with the water, you know, in the same direction that the water's being pushed.
Okay.
And so look, I recreated this experiment inside of a cargo van. It's basically both questions in one, and I want to see if you can get it right. And this is to see if you're really smarter than a 5th grader. So this is both questions in one. Can you tell what direction I accelerated? There's a helium balloon and an apple.
It's either left or
No. I only accelerated in one direction. The accelerate to the right.
Going either.
Yeah,
this
right,
way
left, or yeah, only right or left. What direction did I accelerate?
Right.
Yeah, right.
Right.
Yeah, you got it. Because that's the direction that the balloon got pushed. So
Right.
that's the direction that the air was also being pushed.
Right.
Again, the apple just got left behind.
Right.
You know. So here's the thing. Here's a bonus question. It looks like the apple and the balloon are both moving away from each other, right? And that's what it looks like. But in reality, only one of those two has true motion, and the other one has apparent motion. Apparent motion, meaning it's not really moving, but it only looks like it's moving.
perceived.
It's perceived motion only. So out of the apple and the helium balloon, which one has true motion?
I mean, it doesn't really matter.
Alright, let's see this right here.
Let's see. True motion. I don't know. What can you?
True motion is something that's actually moving through space.
That's like.
Actually moving.
It's
So
actually-
so this has true motion right now.
Right,
'cause
it's
I
actually
moved
moving,
it.
but
Yeah.
apparent is like something that.
So
is
apparent
moving.
will be if I have the phone here, kind of like floating, but I move the table, but it looks, but everything with the
Oh,
table moved. But
yeah,
this,
yeah.
it looks like this is the only thing that moved.
Yeah. It's gonna be. Then it's gonna be. It's gonna be the helium balloon.
The helium
That's
balloon has true motion. Yes, you got
The
it.
reason why I know is because like it may be similar, but if you're like on it's called a
Train?
Yeah, if you're on a train on top of the train, you jump.
Oh, okay.
The train is. I don't know if this is correlation, but if you jump, the train still moves, but you're in the same like spot, but the train is gonna be in a different spot.
Fair enough. Nah, like if something is hanging from a train, for example, and the train moves forward, that object's gonna get left behind until the string pulls it.
Correct.
Yeah. So yeah, that only has apparent motion of it swinging back. That's
Right.
because the entire environment is moving forward.
Right.
Yeah, exactly. So yeah, you got it. Pretty
So
cool.
So
Yeah.
so what are you trying to?
So here's the real reason why I'm doing this. So one last question before and then I'm gonna get to the topic. So if I have a helium balloon here on Earth and I release it, what direction does it go?
Goes up?
Why do you think it goes up?
Air. So based on what you said, air is more
Dense than helium.
More dense than helium. So maybe something to do with gravity.
Yeah, it does. So here's the reality. So gravity as a pulling force has never been measured or detected, and that's why it's just a theory. The fact is the force of the Earth is actually a push. So right now you're not being pulled down to the Earth. It's the Earth literally pushing up against you, and that's what's creating the air pressure here on Earth, and that's why air is able to push heliums up, because the air is also being pushed up by the literal Earth underneath. So again, gravity as a pull, again, it's just a theory. The only real force that exists is the upwards push of the Earth, which is called the normal force.
Okay.
That's what it's called.
So how is that not a theory? And gravity is.
Yeah, because buoyancy, there's devices that we have here on Earth that can measure and detect the upwards push of the Earth, which is buoyancy. So buoyancy is a force. It's an upwards push. Gravity, on the other hand, so when I have an object and I release it into free fall, there is no measurable force that basically accelerates it down to the Earth. So every accelerometer here on Earth, that's a device that detects acceleration, doesn't detect that downwards acceleration because there is no downwards acceleration.
So what does it detect?
It detects an upwards push of the Earth. So accelerometers detect an upwards push as well.
Oh.
So yeah.
So there's a measurable number for buoyancy.
Yes, it's a force.
It's a force, but it's not the same as like
Yeah.
gravity. I know like I don't know what the number is, but there's a gravity. There's like a gravitational pull number. Right?
So the upwards push of the Earth is measured by 1G.
Okay.
So 1G, you've heard of 1G, right? No?
Maybe
Okay, fair enough. So something in free fall has 0G.
Oh,
0G.
okay, yeah.
So I don't know if you've ever seen parabolic flights when people look like they're floating in an airplane when it's doing like a 0G flight. That's because there's no forces acting on you. It's like you're floating in space.
Right.
So something in free fall is not accelerating down to the Earth because there's no forces acting on you. The fact is the Earth literally coming up to meet you. So that's the reality. So the Earth is literally moving up through space, and that's what's creating buoyancy.
The Earth is moving up in space?
Yes, that's what gravity is. It's the upwards push of the Earth, the upwards motion of the Earth, the entire Earth. So, and then anything that's not connected to the Earth, again, it just falls behind due to inertia. So it only appears to move down. So objects in free fall only have apparent motion. Everything else has true motion. Buoyancy is true motion. So here's the reality. So here's why I'm doing this. You believe the Earth is a ball, right?
Yeah.
So you understand that on a ball, up is relative. So if you're standing here, up is this way for you, but if you're standing down here, up is this way.
Right.
Up is, in every direction away from the center is up on a ball. If we could prove physically that gravity is actually a push of the Earth and not a pull, and physics shows us that, buoyancy shows us that, how can the Earth push up in every direction at the same time if it was a ball?
How can it push up in every direction?
Yeah, if it was a ball. Like if the Earth wasn't pulling you towards it, but it was actually pushing up against you, how can that work from a ball? Yeah, it wouldn't work. It would mean the Earth would have to be expanding to be able to push up in every direction at the same time. It would just explode.
Exactly.
So in order for people to believe in the ball Earth theory, they first have to believe in gravity being a pull of the Earth. Because if we could prove that it's a push of the Earth, then the whole globe Earth concept falls apart. So that would be the number one proof to debunk the globe Earth, is the fact that gravity is a push, not a pull. So the fact is the Earth is just an extended level plane that's pushing up in one direction. So we're all standing on top of the Earth, on the same side of the Earth.
You're not okay, but you're not saying Earth is flat. You're saying
it's level.
It's level.
Yeah, and there's a difference between flat and level. Because over 95% of flat earthers, online especially, are claiming the Earth is motionless. So they're claiming that when you release an object into free fall, that it also accelerates down to the Earth. So they're basically claiming gravity as well, but they're calling it something else. So this whole motionless flat Earth versus globe Earth is a false dichotomy. So the whole flat Earth, it's bullshit because they claim it's motionless. The fact is, it's the Earth pushing up against us.
So what's the difference between, so just to recap,
Yes.
what's the difference between it being level and it being a true
Sphere?
ball, a sphere?
Okay.
So I know you said, like, obviously if it's a sphere, then it would just explode because it would have to be expanded.
Yeah,
everywhere.
to be able to
So
push up.
So what would Earth look like if it was a true sphere then? Like,
Okay, so if the Earth is not a true sphere, I don't know what it looks like as a whole.
Right.
All I know that the surface that we live on, all life lives on, is a horizontal plane. So what it looks like underneath and what it looks like outside, like a God's eye view, nobody has that view of the Earth. So NASA, they claim to go to outer space, right? And they show us these CGI images of the Earth, and they admit they're CGI, by the way. They admit they don't have real photographs of the Earth. But everything they're showing us from outer space and about outer space is all just CGI.
oh, you believe it's, or that's something that they said, that's something that they proved? That's...
So they claim to go outside of the Earth, right? And they take pictures of other planets, supposedly, but all of that they're showing us is all CGI. It's not real.
I heard something about, like, most pictures we see of Earth aren't real.
Yeah.
So, I mean, I could see that, but I don't really have an opinion on this because I don't know the facts or anything like that.
Let me ask you this, though.
Yeah.
Sorry for interrupting, but you believe the Earth is a ball, obviously.
Yeah.
Why do you believe it? It's a ball.
So there was an experiment that they did where, and I'm not sure if you're familiar with it, but they had like a pole or something like that, and they measured it they measured some distance.
A pool?
Like a
pole.
A pole, yeah.
A pole, okay,
or
pole.
something like that.
Yeah,
And then they had like a telescope or something like that,
Okay.
and they measured it between a distance. And if the Earth was flat, as most people believe it's flat, then you should be able to see that light coming from that.
Okay, so you're talking about like a laser experiment? They had like a pole with a hole, and then at the end of the lake or something, they had another pole with a hole at the same height, and then they shined a laser, but it didn't go through. Okay, so I'm gonna tell you, so that was an inconclusive test in my opinion, I'm gonna tell you why. So if we shine a laser through water, is that laser gonna go straight?
No, but I don't think so.
No, it won't, because of refraction.
I don't.
So for refraction, so the air is basically moisture as well. So it's like a fluid. So if we shine a laser through the air, we're also going to get refraction. Not as strong as in water, but we're still going to get refraction. So we're always...
Air's moisture.
Yeah. So,
air pressure and stuff?
no, because just the air is moisture. Shining a laser through like water pretty much is gonna distort the... It's not going to go perfectly straight, obviously, because it's going to be... refraction, right? So there's a better test that we can do to actually measure for the Earth's curve. And but before I get to that, do you know the size of the Earth?
No idea.
So it is, they claim it's 3,959 mile radius, which is this distance from the center to the outer circumference. So using a simple calculation like the Pythagorean theorem, a squared plus b squared equals c squared, we can calculate for how much curvature there should be every mile based on the radius they're telling us. So it turns out there should be 8 inches per mile squared, which means in the first mile there should be an 8-inch curve, second mile 32 inches, and by the third mile there should be 6 feet of measurable curvature. And in 10 miles is 66 feet, which is like a 6-story building. So how do we measure for that curve, right? It's very easy. It's better than a laser. So if we go out to a giant lake that was 3 miles across, for example, filled with water, and we build a level structure above it, when the water's at rest, it's going to be parallel to anything horizontal above it, because that's what water does. It takes the shape of the container, but the surface always collapses and forms an equal surface, which is level. That's what lakes do. They're trying to tell us that the surface of every lake is bending 8 inches per mile squared, which is a physical impossibility for water to do that. So they're claiming a 66-foot drop in 10 miles, which is like a 6-story building. So if you went to a lake that was 10 miles across, they're trying to tell you that the end of that lake is 66 feet below you than the starting point, which is physically impossible.
So let me go back to your original point. I'm asking you just out of curiosity. So
Sure.
your original point was that the Earth is
Pushing up.
and there's everything like that we see down.
Well, inertia. Inertia is what basically makes it so the Earth catches up to you again, because your body has inertia, it has resistance to motion.
Wait, define inertia.
So inertia is just the resistance to motion.
Okay.
Nobody knows exactly what the cause of it is, but it's just resistance to motion and change in motion.
Okay.
So the reason why this ball gets left behind when I accelerate the container is because the ball has inertia, right? So right now, if you jump, the reason why you don't continue to just go up is because not only is the Earth underneath you moving up as well, but your body also has inertia. So it wants to remain in its position. When you jump, you slow down instantly, and the Earth just catches up again. So you never move down.
Okay, so going back to what I was going to say, because everything on the Earth has inertia, that's what you're implying. So why is it that if I go however far where it starts to bend, according to this, that it wouldn't just be level, like in my view or in my perception, because the Earth is being pushed up? Like why wouldn't this look level if I'm here versus here? You know what I'm trying to say?
Why wouldn't it look level?
Well,
I would say because it's not level. That's why it wouldn't look level.
Why would it look level? Like if I'm standing at, let me rephrase my question. If I'm at this point of the lake,
and the starting point,
right, and then I go over here, I teleport over here or something like that, it's gonna look leveled. Both places.
Visually,
And what I'm thinking is because if I'm going off of you're saying that the Earth is being pushed up and you're pushing down, like that makes sense for the Earth to look like this, because no matter where we are, we're going to be pushed up. So if I'm here, the structure is going to be level. I don't know. Does that make sense?
Not really.
Where am I losing you?
Okay, you're losing me because when water's contained and at rest, like on a pool, for example, would you agree on a pool the surface of that water is a horizontal? Yeah, right. What if we increase the size of that pool? What if we went to a lake? Would you say that the surface of that water is like a mirror, perfectly level? It literally reflects mountains perfectly straight. Because if it was slightly warped, the mountains wouldn't reflect like a mirror.
It does.
But they do.
It does show balance.
But maybe when there's waves, right? But as a whole, the body of water as a whole is pretty much horizontal, besides the inches of waves, right? My point is, the globe Earth claims that that's not the case, that's only visual. If we actually went out to measure, that there's going to be curvature there. What I'm saying is that curvature is actually not there. They're claiming it's there, but if we physically went out to measure the surface of water by building a level structure, like a giant ruler above the water, that water, the surface of water is going to be parallel to that structure, because that's what water does. Water is the number one tool for measuring level, and that's why we use liquids in these, because water always levels out when contained. So the fact that the lake, water, the lakes are basically containing water, that surface of every lake on Earth, even the oceans, are perfectly level. So they're telling us that no, they're bending, but that has never been measured or detected. So this will be the number 2 proof to debunk the globe Earth, is the fact that there is no measurable curvature, and water shows that is physically impossible. And the number 1 proof is the fact that gravity is a push, not a pull, because you can't have an Earth pushing up if it's a ball.
So when they say gravitational pull, it's more just like
gravitational. Again, it's just a theory that they want people to believe, because they want people to believe in the ball Earth.
Okay. Yeah. I mean, I don't have the expertise to debate on this, but I mean, it was interesting hearing your perspective.
Here, let me give you my channel, and I go to UCLA, I go to UCR, and you could take this with you. Inside of the 6 top proofs that debunk the globe Earth, on top of the number 1, which obviously is gravity is a push, not a pull. But appreciate the chat, man.
What's your credential? Did you go to school?
No, I didn't. I'm just a physics enthusiast. But I didn't go to college. But my channel's right there in the front. You can check it out.
Check it out.
Yeah, appreciate it, man. Thank you. My name is William. William. Yeah, appreciate it, man. All right, that's it. Way longer than expected. I'm gonna start packing it. All right, that's gonna be it for this one. See you guys all in the next one. Peace.